Greetings all.
Defense Research
Welcome
Project
to
Agency.
the final meeting of the TAC for 2015. If we can get John Chapin and Marty to have a seat, we'll be able to begin. This is a very, very busy agenda. Walter and I have been talking about this. We felt like we were really crossing a new frontier by adding a half an hour to the TAC. Then we started lining out the time that allocated and decided that we should have added 2 hours to the TAC, and we'll get to that point towards the end of the session.
Can you put the slides up, please?
Yeah, I think they are up.
Yeah.
The agenda for today, to illustrate this tightness, is help Walt here, is here. So we're going to have our short introduction, a few very positive things in the introduction. We'll do a quick once around the room and check on those on the phone. But you will see up on the screens the lineup for today. Even before the presentations, I think this has been the best year ever topically for the TAC. Really meaty topics and a tremendous amount of work that has been undertaken. So kudos to all of you and those that you represent for a great year. To illustrate the point on the number of people and the amount of energy involved, there are now 49 TAC members. So if we were all here, there would be 49 of us. We're a little short of that number, but we do have good representation today. Non-TAC working group participants, an innovation that we added a few years ago, is now up to 82. So we have, round figures, almost twice as many people involved in our working groups who are not TAC members as we have who are TAC members. And that's really taking advantage of subject matter expertise in many of your companies and in some cases from companies that are not otherwise represented on the TAC. But this has been a great enhancement to the output of the TAC and our capacity to contribute. So really significant. There are 20 FCC liaisons, and obviously the liaisons really are the glue that keep things together and keep things moving. But that's a large group and large contribution from the FCC that sometimes is not as richly recognized as it should be. So the total is 151 participants in our activities. That's a small army, so this is quite impressive. And then the big plus that's on the sign is that's the people who are actively listed on the working groups. And looking at Adam across the way here, you have enlisted, well, your work with NOMI has ended up with a huge number of subject matter experts who have done one-ofs come and speak to the group. So we have, through not all, I single you out, but really this has been a characteristic for many of the working groups where you have drawn from expertise in specific areas to really enrich the output of the working group. So if you listed everyone who has been involved, we're probably 250, maybe more, people who have been involved in the process of producing the output of the TAC this year. And that's very dramatic. And I know this is something that is enormously appreciated by our chairman. Unfortunately, he's not here today. He does send his apologies for not joining us. It is the custom that he would at this meeting, but he is otherwise occupied, and I'll let Julie or Walter give the full excuse. I'm not accepting the excuse, but they can give the full excuse for why he's not here.
And Julie says?
He's out of the country, otherwise he would be here.
Right. No, I did speak to him last week, and he did extend his apologies, so he is quite interested in what we do. Next, I'd like to just briefly, on maybe sort of the converse of the thread that I just suggested, these are the 2014 recommendations from a year ago, and I won't go through them.
These are only the major ones.
I won't go through them item by item, but these were the major recommendations. And the big blue check at the end is the indication that there's been action taken through the course of the year based on the recommendations. And to me, that's the great reward for our work, is that as we put forth actionable recommendations, there is action taken. And that's a kudo to the liaisons, a kudo to Julie and to Walter, and a kudo to Tom for his leadership and focus in that area. But you can scan these for want of time, and I'm already over. I won't go through all of them. I don't know whether you want to highlight one or more. But with that, let's move into a quick once around the table, and we'll keep it brief, but name, rank, and serial number, and then we'll get those on the bridge as well. So,
Walter Johnston, FCC.
Julie Knapp, FCC, Office of Engineering and Technology.
Jeff Forster with Intel.
Eric E. Kuhn with Ericsson.
David Tenenhouse, VMware.
John Chapin with DARPA, here as a special government employee.
Marty Cooper, Dyna.
Nomi Bergman with Bright House Networks.
Lynn Merrill with NTCA.
Teresa Hennessy, Comcast.
Steve Lanning with Viasat.
Marvin Serbu of Carnegie Mellon, here as special government employee.
Pierre DeFrays, Silicon Flatiron Center, here as an SGE.
Lynn Claudy, National Association of Broadcasters.
Greg Lappin, ARRL.
Jack Nishelski from Qualcomm.
Kevin Sparks from Alcatel-Lucent.
Paul Steinberg from Motorola.
Russell Jurek, Cisco.
John Barnhill with Genband.
Mark Bayless from VisualLink.
Adam Drobot, Open Tech Works.
Farouk Khan, Samsung.
Brian Daly, AT&T.
Rob Kubik, Samsung, co-chair with Brian on the Mobile Device Theft Working Group.
Tom McGarry with Neustar.
Jeff Mendenhall, Gates Air.
Mark Richer, the Advanced Television Systems Committee.
David Young, Verizon.
Ramani Pandurangan from Excel Communications.
Brian Swenson, Microsoft.
Dale Hatfield, University of Colorado.
And now could we have those who are on the bridge?
Liberty Global.
Say that again.
Could you repeat, please?
Yes, it's Dick Green, Liberty Global.
Hi, Dick.
Hey, how you doing?
Is anyone else on the bridge? Okay, and I am Dennis Roberson, your chair, and happy to be here with you. And with that, let's move directly to the Spectrum and Receiver Performance Working Group, and Lynn Cloudy, you are on.
Thank you very much, Mr. Chairman. If we could have the Spectrum Working Group slides brought up. This will be the report of the Spectrum and Receiver Performance Working Group. A little bit of background. These are the same bullets for the mission and scope for our working group in 2015 that you've seen before. They are to make recommendations in areas focused on improving access to and making efficient use of the radio spectrum from a system and receiver perspective, to provide support as the Commission considers TAC recommendations related to the statistical aspects of interference, and to conduct analysis and make recommendations related to enforcement issues in a rapidly changing RF environment. This shows the membership of the group, the co-chairs, myself and Greg Lappin, the participants that have been involved in the work, and the 4 liaisons from the FCC who continue to be a pleasure and inspiration to work with. These are our areas of focus for the current period, and some of the outline of our work. Each of these 3 items will be presented by the principal leader of that subgroup for this meeting. In the case of the first 2 bullets, the principal author of the white paper will be making the presentation, the white paper that has been, 2 of which have been distributed to the TAC for consideration and for which we will seek approval today. So Pierre De Vries will start and talk about progress in the risk-informed decision-making area, and he'll present the white paper on METSAT and LTE interference as an example. We will ask for approval of the white paper after his presentation, and then go to Greg Lappin, who will present the white paper on basic principles for assessing compatibility for spectrum allocations, which was also distributed to the TAC previously. And then we'll ask for approval on that document and move to Dale Hatfield, who will talk about progress and our future work plan for recommending strategies for interference resolution and enforcement. So we'll just get right into that, and I'm going to seamlessly turn the remote over to Pierre for his presentation.
Great. Thank you very much, Lynn. So we're going to talk first about risk-informed interference assessment. This is work that we've been doing over the last 6 to 9 months, which is a follow-on from work we did last year. A lot of people contributed to this work. I just want to flag a few of them. We had a lot of really great help from the NTIA, from Ed Drisella here in D.C. and Paul McKenna in Boulder. Roger Peterson at Robeson Associates was very helpful. In the working group, we had contributions from Kumar Balachandran, Bruce Judson, Dave Gurney, and Jeff Mendenhall. And probably the most important contribution came from Uri Livnat, who actually wrote the Monte Carlo simulation in MATLAB for us, without whom this work really would not have been as interesting as it turned out to be. So let me just recap. You've seen these topics and concepts a number of times. What do we mean by risk? Well, we use the risk triplet, which is what are the things that can go wrong, how likely are they, and what are the consequences? And this is a complement to the more traditional use of worst case, which is pick the one thing that can go most badly wrong and don't worry about how likely it is. For us, this method is the application of something that's been done in many other industries for decades. So we apply it to spectrum. We call it risk-informed interference assessment, and that's the quantitative analysis of the likelihood and consequence of interference, particularly between incumbent systems and new entrant systems. And what we did last year, and this was the paper that the TAC adopted in April of this year, was to outline a method for doing this, a 3-step method. And we also recommended that the FCC start developing expertise in this area. The work we're debriefing today is an existence proof that the method actually works. We took a particular case study, the METSAT LTE coexistence in what's become the AWS-3 band, and that's in the document you got 3 weeks ago and that we're presenting to you today. So to just briefly recap the case that we're looking at, this builds on the analysis that was first done in the Fast Track report and then extensively studied by the SISMAC Working Group 1. There is a band where there are weather satellite receivers, METSAT, meteorological satellite. The receivers are fixed Earth stations. You can see a picture of one of them there, very high gain. They track the polar satellites that come overhead, typically about once a day. Sometimes you don't get a good pass every day. And there's half a dozen or so of these satellites. The interferers are LTE handsets, mobiles, UEs, call them what you will. And typically the analysis that was done by Fast Track and SISMAC was co-channel. We extended that and looked at the adjacent channel as well. And so the method that was recommended that we applied was 3 steps. The first is you make an inventory of all the hazards. Now, broadly speaking, there are 3 kinds of hazards. There's non-interference hazards, so just things going wrong with the service absent any interference. We didn't look at that. And then there are co-channel interferers and adjacent channel interferers, and we looked at those too. The next step in the method is to figure out what you mean by something going wrong, and we call that the consequence metric. We actually used, and this was very convenient, the ITU has a recommendation for protecting weather satellites, SA.1026, for those of you who keep track of the numbers. And they, in fact, define 2 interference protection criteria, and I just want to talk about them briefly since that's a key part of the analysis. There's long-term and short-term protection. So long-term assumes that the satellite is very low on the horizon, so it's only 5 degrees above the horizon. The standard specifies an interference level that can't be exceeded more than 20% of the time. And then the short-term interference protection criteria is more stringent. There's another power level. it assumes that the satellite is actually 13 degrees above the horizon, so looking higher into the sky, further away from the interferers, but that level can't be exceeded more than 0.0125% of the time. So with those consequence metrics, you then assess the likelihood and the consequence for these interferers using Monte Carlo modeling, and that's what we did and reported in the paper. To tee up the results, I want to show you this slide, which should hopefully be familiar. It's like, no, not that slide again, because whenever anybody talks about risk, you see this slide. You've got consequence across the one axis and likelihood on the other one. This is the qualitative chart with risk increasing from very low risk bottom left to high risk top right. The work that we did over the last 6 months was essentially turning this into a numerical quantitative chart. There's 30 pages on this in the document that I hope you enjoyed. So I'm just going to summarize it and just give you a flavor of what we did. So this is one way you report the results. So this chart, let me just briefly explain what you're seeing. Along the x-axis, the horizontal axis, is the aggregate interference that the METSAT receiver is receiving. And on the vertical axis is the probability that a particular interference level is being exceeded. The red line, the solid line, is the co-channel interference. And then the two dotted lines, so the green and the blue, are from the adjacent band. And in fact, this chart is a risk chart, just like the one I just showed you. Because on the horizontal axis, you've got the consequence, which is aggregate interference. And on the vertical axis, you've got a likelihood. And you can see that risk increases from left to right. Now, recall that I said that there were two scenarios that we had to look at. There's one chart there. Okay, here's the other one. So for long-term interference, and that's typically what people think of as worst case, right? The antenna is very low to the horizon. You're going to pick up a lot of interference from your LTE mobiles. The area that you can't get into is that red block in the top right-hand corner. That's the ITU interference protection criterion. And so we choose the exclusion distance for the red line so that we don't get into that area on either of the two charts. And so on the right-hand chart, you can see I show the short-term interference protection criteria, and it's a different area. Briefly, how we calculated this. We did Monte Carlo, as I said. We pick an exclusion radius. We deploy UEs randomly, deploy them according to a density, suburban or rural, depending on how far away we are from the METSAT receiver. So that's random. For each UE, we calculate the distance to the METSAT receiver. So we can calculate the median path loss. We then add a location variability, which is sampled from a distribution. We sample the power of the UE from a distribution. And then in the case of the adjacent channel, obviously in the adjacent, and this is the AWS-1 band, the contribution into the METSAT is out of band emission, and so there's an adjacent channel leakage ratio. We sample that out of a distribution. And then you do this for each radius. You do this a lot of times. So for the chart on the left, we did it 10,000 times for every radius, and the chart on the right, we did it 1,000,000 times for every radius. And then you just increase the radius. So that's the method. Let me just briefly point out one thing that's interesting. If you didn't stop me, I could talk for half an hour about these charts, but I won't. I just want to pull out one interesting consequence. So I've highlighted there the distance between the red chart, which is the co-channel. Oh, that's interesting. Between the co-channel interferer and the red zone. And you can see that it's closer on the short-term case. It's closer on the right, which means that the binding constraint is actually when the antenna is 13 degrees above the horizon, not 5 degrees above the horizon. So in fact, what everybody tends to think of as the worst case tends not to be the worst case if you do this analysis. Much more we can say about that, but let me move on then to our conclusions. So 4 broad conclusions, and there will be 4 recommendations that tie to these conclusions. The first is the method that we proposed works, right? Monte Carlo allows you to combine fixed values and probability distributions. You can add probability distributions. For example, with the out-of-band emission, we started with a fixed number for the UE's adjacent channel leakage, and then we added the distribution. The second conclusion is that you do get interesting insights. So, for example, the binding constraint is not what you thought the worst case was. The third conclusion was that the statistical protection criteria that we were able to use, in other words, a power not to be exceeded some percentage of the time, is really helpful when you're doing risk assessment, probabilistic risk assessment, because it gives you the probability. And then lastly, our analysis was constrained. Two important things. One is the absence of baseline information. When you're trying to say this is risky, really you want to be able to say risky compared to what? And so for that you need a baseline. And we weren't able to really get baseline information about the performance of satellite systems. The second is we were relying on the ITUR recommendation, and the documentation of how the numbers in those tables magically appeared are, shall we say, inadequate at best. So that leads me to our 4 recommendations. Firstly, that the FCC continue to pursue adoption of this method, as we described in the April paper. So, for example, one of the things I think that would be interesting to do is to see if the U.S. government can advance the case for doing risk assessment in ITU studies. Further, the FCC has already started pushing ahead on some of the recommendations that our working group made in April. I gather that some of the staff has already started doing training in risk assessment. The second recommendation is for the FCC to adopt statistical service rules more widely. This will make future risk assessment easier. This is something that the FCC has done in the past. If for those of you who know broadcast protection contours, right? It's a field strength not to be exceeded a percentage of locations in time. So this is something that the FCC has done. It's done more recently, for example, in the 3.5 proceeding as well. The third recommendation is to encourage services that seek protection to disclose their baseline service protection so that you know what you're comparing to. And then last but not least, to encourage all parties to disclose the methods that they use when they come up with interference protection criteria or when they actually do coexistence assessments. So that's the presentation on risk. Lynn, back to you.
This white paper is a specific example of the techniques and principles that were in the paper that was approved in April by the TAC on an introduction to risk-informed interference assessment. So we think it makes a great companion with that earlier work and kind of brings the concepts to light in an informative way. And Mr. Chairman, we would ask, first of all, if there are comments on the paper itself or on Pierre's presentation, but we would like to ask that the paper be published on the TAC website as a product of the TAC for the benefit of others outside that would benefit from its publication.
Mr. Chairman?
Yes.
Well, a quick comment here. I think this is an excellent paper, of course, and a suggestion I would make is that I know the FCC typically sends one representative, at least, to the ITUR meetings. And would it be possible to task that person to take this paper and make it a contribution to the ITUR's work? That way, I think it's valuable because I think it's new compared to what the ITU has been doing, and it would be, I think, very useful to them because it verifies some of the methods, and it also points out that we don't have as good a data as we need. I don't know, Julie, is that reasonable? Is that something we could do?
Thanks, Dick. I think it's something we can explore with the International Bureau and the reps. I don't know about the mechanics of which would be the right venue and so forth, but it sounds like a reasonable idea.
Well, thanks. I think if the TAC approves this, then this might give you a platform to, provide a contribution to the ITUR. And I agree. I don't know exactly what the mechanism would be, but I think it would be worth looking into if we can. Thanks.
No, I think that's a great suggestion. Good. continue on?
Well, we request to have the approval of the white paper for publication on the TAC website.
So is there, well, all in favor of this approach? Hopefully you have all had a chance to review this since it's been out. I know that's difficult for many of you, but all in favor of the publication of this as a TAC document? By approving, you are certifying that you do support it, independent of whether you fully read it. all in favor, raise your hand. Opposed, same sign. Seeing no opposition, we'll look at that as being unanimous. So we will ensure that we have the publication.
Thank you very much. We're going to move now from the very specific to the very general, and Greg Glappin is going to talk about the white paper on general principles for the FCC and spectrum allocation that his subgroup has developed.
Thank you, Lynn. Like Pierre, our subgroup has also come up with a white paper, and at the conclusion of this, we're going to also ask for the TAC approval on that white paper, which hopefully you've all seen and read. That white paper was presented, put together by myself with a lot of help from Kumar Balachandran from Ericsson, Pierre DeVries from Silicon Flatirons, Dave Gurney and Steve Kuffner from Motorola Solutions, Dale Hatfield from the University of Colorado, Bruce Judson from Qualcomm, and Bob Miller from Inc. Networks. The basic principles are presented to the Commission in the allocation of frequencies to services. The principles apply to incumbent users, to new entrants desiring spectral space, and to regulators. When followed, they provide maximally efficient use of limited spectrum. And we're, again, requesting that the TAC approve the white paper at the conclusion of this presentation. One thing that has to be made clear is that our principles do not propose a one-size-fits-all set of policies. Rather, they are principles that aim to facilitate the most efficient application of frequency allocations in order to realize the most effective communications in the face of interference. Harmful interference is not redefined. It's defined in several places, and we're not trying to redefine it, but we have envisioned what it means a little more concretely than is written down. We came up with 9 principles, and they can be divided into 3 categories. The first category is interference realities, which means what users of the spectrum should expect in terms of interference. The second category, responsibility of services, what systems need to do to minimize the effects of interference, and regulatory requirements and actions, and that's directed at the FCC to help them allocate these frequencies. The first category of interference realities starts with the concept that interference exists. Everyone should accept that. It's physics. Nothing we can do about it. No service should expect to inhabit a perfectly silent frequency. All services should expect that the interference they experience today is not likely to be the interference that they will be faced with tomorrow. And whether or not interference becomes harmful depends on the actions of all the services involved, not just any one of them. So our first principle, harmful interference is affected by the characteristics of both a transmitting service and a nearby receiving service in frequency, space, and time. Interference can become harmful or not due to changes by the transmitter or the receiver. Interference between 2 services is affected by how much spectrum is placed between them, how much physical space is placed between them, and if services can coordinate their operations to occur at different times. Our second principle, all services should plan for non-harmful interference from signals that are nearby in frequency, space, or time, both now and for any changes that occur in the future. Today's interference may not be tomorrow's interference. As new entrants are introduced to the spectrum, existing conditions are bound to change. Planning ahead for future changes will make it easier to deal with changes when they occur. Third principle, even under ideal conditions, the electromagnetic environment is unpredictable. Operators should expect and plan for occasional service degradation or interruption. The Commission shall not base its rules on exceptional events, those being changes in propagation, most of which are temporary, intermodulation effects, which can be transient, and the conditions that exist over a majority of the time are what should be used to set policy. We move into our second category, responsibilities of the services. With the main concept being that the FCC does not provide a brick wall to separate services. Neighboring services must be good neighbors. Just like you and your next door neighbor at home, two users of spectrum have to respect each other so that they don't impinge on each other's operations. Methods that allow more closely spaced services while maintaining an acceptable interference environment should be used whenever possible. But we need to keep in mind that some services exist because of low-cost devices, which may not be compatible with advanced interference avoidance techniques. Our fourth principle, then, is for receivers. They're responsible for mitigating interference outside their assigned channels. And this diagram is a picture of a receiver blocking mast. It's the inverse of what we see more often is a transmission mask. But it says essentially the same thing, that the receiver, as it moves away from its own channel, has to be able to block a certain amount of signal that's in the frequency space outside that channel. Principle 5 is directed at systems, transmitters and receivers together, and they're expected to use any techniques they can at any layers of the stack to mitigate degradation from interference. And I'll mention that stack is a loose term here. I put it in quotation marks because even non-digital old technologies still work at layer 1 and layer 2 of the stack. So we're using the term stack loosely that way. But some examples that have been used and could be used are directional transmission, directional reception, multi-input, multi-output, or MIMO antenna systems, power control to reduce the amount of transmitted power to the minimum amount that is necessary for communication, using frequency hopping or spreading, using adaptive modulation and coding, using channel codes, using more advanced receivers that are capable of rejecting interference, interleaving in time between two different users, retransmission, or in essence, if there's an error detected in data that's transferred, you send it again, and scheduling. You choose times that aren't as busy to avoid the interference. The third principle in this category is for the transmitter. And this is something that the FCC already regulates. The FCC, in many cases, provides a transmission emission mask to show how much energy is allowed to go outside of an assigned channel. However, possibly a new concept is that the transmitters should minimize the amount of transmitted energy that appears outside their assigned frequencies, even below what's required of them by regulation, if they can. Third category is regulatory requirements and actions. So the allocation of spectrum can be made intelligently if sufficient information about the services is available. If we assume that our societal goal is to maximize the use of spectrum, then minimizing the guard bands, the space between different frequency channels of different users, while keeping an acceptable interference environment is the key. So Principle 7 says that services under FCC jurisdiction are expected to disclose the relevant standards, guidelines, and operating characteristics of their systems to the Commission if they expect protection from harmful interference. Now, obviously, this was something that there was a lot of discussion about, because there are a lot of reasons why, say, a military system wouldn't want to divulge too much, or even for competitive reasons, different users wouldn't want to divulge too much. And we accept that, but we also realize that the FCC, in order to do its job properly, needs full details about the operation of services to make informed decisions. And they can't be expected to be as effective in avoiding interference without that information. So if we're not saying that a service is required to give up all that information, but if they don't, they should realize that they may not get as much protection from harmful interference as they would if they could give that information to the FCC. We didn't go any further than that. We're not trying to set policy, but that's a principle that I think holds fast in any case. Under the same principle, though, the thing that the FCC really needs to know is what is the minimum expectation of performance that a service needs. That way, the calculations can be made and the FCC can make the allocations in order to prevent interference from becoming harmful to that service. Harmful, again, is a moving target. And if interference exists, but it does not prevent that minimum expectation of performance, then it's not harmful anymore. And if we go back to our earlier principles, that can describe how a service can take interference and make it non-harmful. Services should realize that if they do not want to or cannot make full disclosure, they're preventing the FCC from helping them. And we suggest that the licensee community of interest cooperation using an internet-based secure clearinghouse to assist the FCC and speed selective interference mediation be examined. And that may be something that we're proposing to look at for next year. Principle 8. The Commission may apply interference limits to quantify rights of protection from harmful interference. I won't go into depth about interference limits because of the time involved right now, but we've already published 2 papers on the subject, and I'm sure you've all read them. So if you haven't, here are links to them, and you can, after the meeting, go look them up. But in essence, what that says is that interference limits at each receiver determine when interference becomes harmful to that receiver. And if we can calculate those things for each service, then the FCC has a way to go in and find out if harmful interference is occurring. I think I lost this. Can I get the slides back?
I think we might have. Here it comes.
Thank you. Principle 9. This we spend a lot of time on as well, and it's very important, and we'll need more time in the future. But a quantitative analysis of interactions between services will be required before the Commission can make decisions regarding levels of protection. Standard modeling should be used by all services. That's the definition of standard modeling is something we need to work on. but a clear statement of assumptions and initial conditions also must be provided. You can use one model with two different sets of assumptions and come up with two completely different solutions. The FCC should have enough detail so that the models can be reproduced, and models of adjacent services should be harmonized into a single set of calculations. And what I mean there is that if you have two different services that make submissions to the FCC and each does a model of its effect on other services, if those two models are not harmonized, the numbers have no meaning. You really need to put them together into one model for those two services and see how they interact with each other. One of the important concepts that came up is the concept of transparency and reproducibility of calculations. This is something that is not foreign to our academic world, but often in the technical world, people will do a lot of calculations and present the results without saying enough about how they came to those results. If they do so, then they may have made a mistake and no one will ever know it. Whereas in the academic world, if someone publishes a paper, they are required to be transparent enough that anyone else can go reproduce those results, and very often that reproduction points out an error that occurred. So that should be the case here too. Any interested party that wants to reproduce the results should be able to, but to do so they need access to all of the information that's needed. And if everything were as transparent and reproducible as we would like to see, then that's the best way to ensure that our modeling results would be correct. So, in summary, what we're saying with these principles is that it is in the best interest of society that spectrum be utilized in the most efficient and effective manner. And by following these principles, we'll end up with the best allocations of frequencies for both the interests of society, which wants the most efficient use of spectrum, and for the services that wants as little harmful interference as possible. So our recommendation to the TAC is that the Commission adopt these 9 principles in its future deliberations of frequency allocations to new services. Lynn, back to you.
So this white paper was originally distributed to the TAC right before Thanksgiving because there was concern people wouldn't have anything to do over the holiday. And then a final version was distributed this past Monday, which was primarily just editorial fixes and the addition of a summary at the end of the document. We did receive some comments, and I think they were good comments, but I don't think they changed the paper itself, but probably have some impact on future direction the work might take. So we're looking for additional comments on the paper now, and after that, depending on what those comments might be, we would like to ask the TAC for permission to publish this paper on the TAC website.
Any comments from anyone?
Just a quick question and great distillation of what I think would be very helpful principles. I'm wondering about the motivation side, particularly around harmonization between users in adjacent bands. And I didn't see that at all addressed. And it would seem that to users that both invest in capabilities that allow an operational harmonization, where the shoulders of one go into the range of another, and the neighbor adapts to that there ought to be some incentive to actually invest in those operational harmonization capabilities. Did you look at that, or do you think the static harmonization would be sufficient to incent the right behaviors, just because theoretically you can get more out if you do this statically?
Well, that's a very good suggestion, and it's something that we didn't consider. We tried to be as general as possible, so that to leave the regulators or the FCC up to give them the freedom to put different services next to each other in any way that they wish, as long as they meet the interference principles. But that's a good suggestion going forward. After having done that, it's a way that we really didn't think of to minimize that interference.
The thought would be, so many times the intermods have real regional and building morphology kind of variation that makes results different when you actually deploy. And if there was any kind of a mechanism where credits by allowing your neighbor to infringe upon your spectrum in one area then would be applied towards when the next morphology favored the other neighbor, then I think you'd be more likely to create win-win scenarios where it's in the best interests of both to, in fact, become good neighbors.
I think that's a very good suggestion. And it is along the lines of something that we're going to be proposing to study next year, and that's modeling, to be able to model those things and show that they would work well together.
Pierre, would you like to? We are.
Yeah, just a quick.
As we worry, we are running out of time already. But
yeah, just a very quick point to Admiral Simpson's observation. One of the things that, in fact, I think it's Principle 7 or 8. Talks about interference limits. And indirectly, it addresses the issue that you're interested in, because one of the uses of interference limits is to be clearer about the responsibilities of parties on either side, therefore makes it easier for them to do exactly the kind of negotiations you have in mind.
Any other comments about the substance of the... Yes, John.
Two things. Actually, no comments about the white paper, which I think distills a lot of interesting ideas. The specific language of the recommendation that you're asking us to vote on caused me a little bit of concern because some of these principles are quite aspirational. It would be quite difficult to fully implement them in a future allocation proceeding. So it might be nice to have the recommendation state that the Commission should adopt these principles where practical or where possible or something like that, being a recommendation I would feel more comfortable making to the Commission. The other thing is that you use the word services, frequency allocations to new services, and I'm wondering if you actually meant that in the technical sense of the mobile service versus the fixed service, or if you meant it in a more general term. It might be somewhat confusing as a recommendation in that context.
Okay, well, to answer you, I accept your wording change because I think that's a very good addition to the recommendation. And secondly, services was meant to be very general. We could have said users or service. What's the other? There was another term that we used as well, but it's allocations of frequencies to different groups.
All right. With what you have heard, what is the will of the TAC around the modified recommendation that is modified by John? And it's really a two-part. One is the publication of this set of principles on the TAC website, and the second is a recommendation that this, which is logical, that this set of recommendations would serve as a guideline for the FCC in the future. What's the will of the group?
Show of hands.
Yes. How many are in favor of proceeding forward? Those opposed, same sign. Again, it is unanimous. Dick, I presume that you're there. I can't see your hand, but I know it's up. Okay, so we'll proceed forward with the modification to the recommendation, and congratulations to the group.
And we're 15 minutes behind schedule.
Yes, and we are desperately behind already. You had one last item, and it's one page, so please conclude quickly.
Yes, sir. If we could go back to the last presentation, and there's one more slide on.
Yep, it's up.
Could you put the slide back up?
And there it is. And this is the work that Dale Hatfield is leading. So over to you, Dale, and then we will pass on to cybersecurity.
Yeah, because I know that of the time situation here, just really, really briefly, with all the changes in technology, the dynamic frequency sharing, and all the sort of software-defined radio, all the sort of activities that are going on are causing a change in the sort of threats that you have to address in the enforcement area. At the same time, a lot of those technologies that are creating new threats are also creating opportunities to do something about it. And it's pretty clear that there's an awful lot of work going on. The Commission here is changing its field operation structure, for example. And the notion is to do some sort of a study which we've labeled sort of a next generation interference resolution and enforcement study to come up with a new architecture. And I won't go through the slide here, but the idea is to develop a statement of work for such a study that would lead to the architecture. And we actually talked about this morning, there's a draft of that statement of work. We discussed it at our pre-meeting this morning, and we'll hopefully have that finished and ready for approval at the first TAC meeting in the coming year.
Okay, very good. It's been a great deal of work.
That concludes our report.
Okay, thank you. I know a great deal of work has gone on, as it has in the other working groups. So thank you for the two papers, and thank you, TAC, for the approval for moving forward with these. And you're on, Paul.
I have the cybersecurity slides, please.
They're up.
So we will do our best to make up a little bit of time. We ran over the last time, so we owe you a little bit back, TAC. So the obligatory slide with the membership, and it's a very large group of folks. Special thanks to our FCC liaisons, Ahmed Padma and Jeff, and extra special thanks to the Admiral. He was very active and engaged and very supportive at various points along the way. Shahid sends his apologies. As a co-lead, he couldn't be here today, but he's here in spirit, and any and all action items or future work go to him.
Very, very effectively.
Yeah, we'll be seeking formal approval on that recommendation in a moment. So I too am a believer in parallel processing, so I'll divide and multi-thread wherever I can. And so we had also 3 groups this year, and actually one was split into 2 pieces. What I'm going to do is, with a couple of my co-chairs who are present, I'll cover the work of Group 1, Subwork Group 1, very quickly, and it's largely what we had done at the last TAC meeting, so I'll be brief. And then I'll turn over to Tom, and then finally to Romani for the subsequent work groups. What we chose to focus on, we published in advance of this meeting 4 papers, 2 actually associated with Work Group 1, and then 1 for each of the subsequent groups. So we're just going to focus here on the recommendations primarily, and just to highlight the key findings to be expeditious. I don't know if we should be requesting approval at this point for publication or not. I wasn't quite sure about that point of order, but as far as we're concerned, we are complete. Paper 3 was sent out in draft form, but the only thing that has changed, and it is final now, are some editorial comments. So I don't know if we submitted them in sufficient time for people to review, or how that works, Dennis.
We will determine that.
Okay. Okay. So, Work Group 1, as I mentioned, there were 2 pieces. The first was really the tie-off from last year, which was really the idea about operationalizing a front-end wizard to actually aid the consumer in trying to assess the cybersecurity, threat parameters when setting up or when they first acquire their mobile device. That work was actually completed at the last checkpoint. The paper was just issued subsequent to that. No additional work was done on that. It was led primarily by Martin Dolly from AT&T and Renato Delator. So the main point of this was, I'll move ahead a couple of slides. One too far, sorry. The main point of this were the recommendations where basically, and this is going to be a recurring theme, to take this much further, the supplying ecosystem, either the mobile OS vendors and in some cases the handset vendors or the carriers need to get more proactively involved to put some of this into motion. And that's probably even more important, which we think is probably the more impactful work for the group with Group 1B. So I'll rest on that. There was a paper published around Group 1A, relatively straightforward. I don't think there's too much controversy in there. I'll move us to Group 1B, which was a little bit more substantive work. Amit Ganju and Katrine Reitzma led that work. And what happened with this was effectively the request was to identify some requirements for a more active and transient smartphone security checker that could be proactively operational on a device. And that work was also, from a recommendations and findings point of view, largely complete back in September. The paper was finalized, and a couple of things were added to it since then, primarily a couple of appendices, which the work basically went through and identified a way to characterize with a front-end script, and we'll come back to that in a second, where the security profile of the device and the user's intentions of using the device could be assessed, and then map that into various security parameters and facilities located on the device, primarily enabled by the operating system itself. And so then what we did was taking all of those security control points, mapped those back in the appendix against the various operating systems, primarily iOS, Android, and Win, to get a sense of how consistent were they and what might be there to facilitate some of those checks. So specifically, the white paper was published with the requirements as requested, and then, as I mentioned, the associated appendices. The architecture was considered in the design, the launch time. Probably one of the key findings was this notion of extracting from the input from the user's intended usage a higher level security assertion level. We still are thinking levels 1 through 4 or 0 through 3 if you prefer, with increasing security and then, of course, increasing controls placed on the risk profile for security. And then as well, we provided the team provided their recommendations around how that might be manifested along the grounds of the operating system. And then we tried to go through in every case where there was a security control or parameter to characterize that and explain how that might be mapped to one of those 4 security levels. And that's obviously somewhat subject for debate in future work. So if we move to the recommendations, the primary recommendation we think, and the key lever point is the mobile OS environment. So getting minimally Apple and Google involved here, and I know the FCC worked pretty hard to try to help us with that along the way. And it just may be something that we need a little bit of help, beyond the scope of what the TAC can accomplish to go to the next level. Commercialization is the obvious next question. There will be issues and flaws, I'm sure, with the suggested requirements and the mappings. There's a couple of ways this could be done. One, as I said, is mobile OS related. The other would be more of an over-the-top, kind of app-based development. And so need to think about who are some of the partners that could actually advance that ecosystem and how does that happen, who would maintain, deploy, support those kinds of capabilities. What's the commercial model? Is it a security ecosystem, the malware providers and those are malware defensive providers? Is it mobile OS? Is it the device providers or the carriers? And then finally, assess and devise that front-end user interface. Can you actually make this friendly enough for a user to actually want to go through the process? We did engage the CAC, again, with some help from our FCC liaisons and the Admiral. I would call it a spirited discussion around their willingness to take this on. And at least they've taken it back to the CAC for consideration as to whether they can get their head around that. And I think that's kind of where we're at right now. So that's a key next step if we can get the front end wrapped around this. So suggestions for future work. We think there's not a lot farther we can think of we can go with this right now, although the Admiral's proved pretty adept at finding new things for us to do that we hadn't considered. But the thinking here is we really need to think about how do we put this into play. And that means we need to probably shift the engagement to, like I said before, the ecosystem, the mobile OS providers, so the people that can actually put this into practice, and to kind of assess the recommendations and consider whether this actually makes sense to proceed. If we need to pivot, or spool up a different tack on this. So our recommendation primarily was around advance this commercially in the ways that only the FCC can, and then pivot to future work based upon where that decides to go and what we can do to further facilitate that. And as I mentioned, there were 2 papers here that I guess we would respectfully submit to the FCC and the TAC for approval for socialization in whatever way makes the most sense. So I'll stop there, and then I'll pass on to Tom.
Any comments on this section or on the papers themselves? And you're on.
Paul, I really appreciate the work of all, and I think it did help move the ball forward on the art of the possible as we go forward, but also distilling what it is consumers really would want in the interaction with their devices regarding security. It was very difficult to get the OS vendors engaged here, yet we've seen great success at the enterprise level as enterprises bring mobile capabilities into their workforce. This whole MDM category, mobile device management, has really taken off at the enterprise level. There's some great products out there. Samsung's Knox operating system has a real focus on how enterprises could manage this environment in a way where they had predictable security with the smartphone. Motorola has a great product, the SME secure mobile environment, and there are a number of others. But there's no mobile device management for consumers. Is this an area for commercial growth? Is this something that the FCC can help facilitate so that consumers who are security conscious can enjoy the kinds of protections that are now being introduced in a very effective way for enterprises? So I'm just wondering if that might fit into the category of future work.
Yeah, it could be. I think it's a great suggestion. I think some of that, and it'd be interesting to get some comments from others. Those things are all kind of motivated commercially. So somebody's going to need to pay for that, I would guess, and somebody's going to want to offer that service and collect the dollars. So probably that's as important as anything else. And maybe a good place to start would be maybe back to the CAC. Maybe they could do some consumer surveys of would there be willingness to pay for such a service or such a capability to protect your data. And I think if you'd asked that question 2 years ago, I think it would have probably fallen pretty flat. Now, I think awareness and concern, at least among the average individual, is increasing. So maybe.
Anybody who's ever had to reload the OS for an elderly parent on a regular basis, or a brother or sister that isn't quite so tech savvy,
yeah, that's true.
I think would intuitively suggest that there is at least some market for keep it simple, stupid, and reliable, and really like a little help in managing that environment so that I'm not exposing my PII and credit cards when in fact with a little bit of extra diligence I could have set that up right. But getting it going, it's kind of the chicken and the egg piece until that is, as you suggest, available in a way that is inexpensive. Right. You're not going to get the customer demand broadly. Anyway, thanks.
No, thank you.
Okay,
Carriers
good.
would be another logical place to think about, potentially standing that service up as well, I would think.
Milo, you had?
Yeah, I just wanted to remind folks that both Google and Apple are making large strides in changing the default settings in operating configurations to turn encryption on and to make the devices be much more security protected, I would say, as a default. I think in many cases what we've seen in the past is security used to be an extra setting that you turned on if you worried about it. But I think now with encryption hardware being built into the SoCs that gives you really crypto at high performance, it's now practical for many OEMs, in the case of Android and certainly for Apple, to turn on encryption as a default. And I think a lot of the industry initiatives are already moving in this direction, even without sort of outside interference, outside prodding.
Very good. Okay, we do have two papers on the table. Well, let me just jump straight to the vote, I think, on this. All in favor of publishing these papers on the TAC website, would you please raise your hand? All opposed? All right, we will publish two more papers. Congratulations to the group. And on to IoT.
Thank you. Slides up, please. So this is our group and scope and approach. That hasn't changed. So our key accomplishments, and this is here for 4Q15. This is not the entire year, but we spent most of our time creating a white paper that covers the FCC questions and the work that we did. We met with Underwriters Laboratory to hear about their plan to create an industry-led IoT certification process. There's some more slides in the appendix on that. And we worked on the FCC's 3 questions. I won't go through them because I think everybody here knows what those 3 questions are. So in the white paper, we have 3 recommendations. The first being the FCC should publish and promote our technical set of considerations for consumer IoT security. The items described in our white paper could be used by the FCC to promote the development of best practices and guidelines with industry stakeholders in this consumer IoT market space. There's a note there. The group did have a long discussion about a recommendation regarding a potential FCC role in convening and or promoting an industry-led consumer IoT certification effort, but we were unable to come to consensus on that, so there is no recommendation on that. But we wanted to put it there because it was a vigorous discussion we had. The second recommendation is the FCC should participate in government IoT security matters with other agencies consistent with the 2014 NSTAC recommendation to address IoT cybersecurity. This was, as we did our research, we realized that the scope and scale of IoT is so vast that it probably would help for the FCC to have cross-organization collaboration. We give a list of some of the groups that are obviously interested in IoT cybersecurity issues. And also the third one, conduct a consumer awareness campaign related to IoT security and privacy in collaboration with other agencies once again. And this is similar to a 2014 IoT TAC work group recommendation. And suggestions for future work. Consider augmenting the consumer focus, which we were this year, with enterprise, ICS, and critical infrastructure focus, perhaps for next year. Or another option is to perform a more detailed evaluation of a specific aspect of IoT cybersecurity, maybe focusing on the communications technologies or resource-constrained devices. That's all I have for IoT cybersecurity before we go on to Ramani.
Okay, so the accompanying recommendation would be to move forward with publication of the white paper that has been circulated.
Yes.
Any comments, questions? David, you're consistent.
Thanks for the work and the summary that you gave us of the UL meeting was useful as well. I do note that one of the hot toys for this Christmas is a Barbie doll that connects to residential Wi-Fi and then to the cloud and engages in a dialogue with a child. Only they had no clue of man-in-the-middle attacks, and Mattel has now, or whoever makes Barbie, recalled that product because of the ease with which a hacker with malicious intent could get in and be a part of that child discussion. So I don't think we've covered this area. If that's what's happening with toys, to not have the industry come forward with the ability for consumers to know where are we in that range of vulnerability that you're exposing me and my family and critical infrastructure sectors that are beginning to look for value in IoT. I think you're leaving the treatment of this risk out there blowing in the wind, and I'm concerned that we're not getting better industry recommendations on how consumers, both individuals and companies, can sort out how secure they are when they incorporate IoT capabilities into their information infrastructure.
If you look at the white paper, we tried to pull in what we called key findings into the executive summary section right in the beginning. The white paper covers a lot of things that are informational. Here are what groups are doing, but it also covers within there things that we came to conclusions on as we were looking at, as we were researching it. And what we found, if I could almost summarize what the whole paper says, is that cybersecurity and IoT is an issue. It's a problem. There is an issue with companies like you're talking about. Mattel has never had to deal with IP before, right? So it doesn't have a CISO. It doesn't have cybersecurity processes. Yet the industry realizes that it is a problem, and the industry actually is reacting to it. There's actually a lot of work out there. That was kind of the consensus of the group at this point. We could not get to a next stage, I admit, of recommending that the FCC do something more specific with regard to how to get involved in the IoT cybersecurity. The thinking was it's early. The industry is reacting. That was really the consensus of the group. But your comments, well taken.
Pierre.
Just to follow on both of those issues, I just want to pick up on your third recommendation, which is that the FCC should conduct a consumer awareness campaign. I think the press has been doing a pretty good job, and the story we've just heard is doing a pretty good job in giving everybody awareness that we're vulnerable. What we're hearing from the group, as far as I can tell, is that the industry has your back somehow, but they can't tell us how yet. So what would an FCC awareness campaign actually communicate?
There you go.
Well, obviously that the communications technologies are vulnerable. What you're working with, your Barbie doll is actually using your communications technologies, and you should be aware that there are risks.
I think the point that Pierre is making is that awareness probably already exists in the main. Yeah.
And you don't want us chilling the market. No. Don't use those communication products. They're dangerous. I'm not sure where to go with the PSA recommendation.
Okay. Now, that recommendation, refresh us, that is in the white paper as well.
Yes. Yeah. And it is pretty close to a recommendation from last year as well.
I think what I'm hearing, others may want to quickly, David?
Just speaking for last year's recommendation, and Russ can correct me, I think we were thinking in terms of not just the awareness, but examples of actions people can take to protect themselves. And the press is not always as good at conveying that, or conveying it in an authoritative and accurate way. It's typically things like just getting the configuration right.
I think what you're hearing from us is a recurring theme that we're missing a language to do that with. And the UL-like guidelines that we'd be able to talk about categories of risk and categories of IoT devices would, in my mind, greatly facilitate just such a PSA as you're recommending. But I don't think that the staff at the FCC is the right group to be assembling that language. You wouldn't want us to. We'll mangle it. I really think that it's in the best interest of the industry that wants to sell more products in IoT and wants to have more and more bandwidth properly utilized and commoditized to help us with that language, so that we're not letting too great a risk exposure at some point come back and have such an egregious event occur that we slow down this all the useful things from marching to IoT.
What we do find is that there are a lot of, like I said, there's a lot of work going on in the industry. A lot of that is around best practices. There's a list of best practices. There's lots of them. We have a sample of them. Most of those are actually focused not on consumers, but on companies, manufacturers, and service providers. And maybe that's a better guidance for the FCC, that they should look at those and maybe think of those as recommendations to the industry as opposed to consumers.
I know. Hearing the concerns, I'm wondering if it might be useful to table this one for one more round and come back and take one more look at it. Is that reasonable? Okay. Let's move to the next topic if we could. We are desperately behind already, as Walter's leaning over and pointing out to me. So, securing SDN.
I said, lucky to go first. That wasn't kidding. It was a good catch.
So our sub-working group's scope was to look at the software-defined networking and, of course, associated with that network functions virtualization, securing these new architectures. What are the threats that are engendered by these new architectures? What are the opportunities? And the team consisted of, service providers, vendors, as a cross-section of that, and also FCC liaisons helping us, guiding us. The accomplishment was, obviously, the whole industry is working on this at a feverish pace. Pretty much everybody saying, everything is going to be fundamentally transforming the way network service will be created and instantiated and delivered. However, we didn't see a lot of best current practices existing. So the methodology we did for coming up with the white paper is really surveyed from industry sources, consulted a cross-section of the industry players like vendors and open source communities and also service providers. And those are the sources we used to come up with the white paper. So the white paper, as Paul mentioned, is pretty much near final except for some editorial changes. Essentially, it traces to give the context architectural attributes of this, both SDN and NFV. We capture the industry landscape where we are in terms of various security aspects. What are the threats? What are the opportunities? And then we look at what are the gaps that exist and then come up with a recommendation. Those are the kind of four highlights of the white paper. The recommendations. So the landscape is represented by several use cases, but they're all very, very specific use cases. Technology deployments are still in the early stages, a lot of proof of concept. Some are a little bit ahead than others, but generally the whole industry is working on this, is evolving. So there are no best common practices that exist today as we were searching for this one. So it is recommended, one of the recommendations is that there are some dominant use cases that seem to be emerging. There are a lot of use cases people are talking about. There are 4 or 5 dominant use cases we identified. And one of the recommendations is that as a first step, get the best current practices to be developed for these dominant use cases. We have listed that in the white paper. Work closely with the industry, all the open source communities, because repeatedly we heard from many of the industry players, a dozen or so we listened to. Although standards are needed for interoperability eventually, most of the quick progress and everything is going to be achieved in the open source communities. So one of our recommendations is that work closely with the industry, like Open Daylight, Open Networking Operating System, Open NFV communities, to sponsor, promote the open source communities, projects to create some awareness as well as opportunities for new developers, which they can showcase their solutions, security solution. Two aspects. One is how do we provide security for the SDN NFV, as well as how SDN NFV can be used to provide enhanced security solutions. The third recommendation is sponsor a workshop to focus on a small number of critical security challenges to see how this can be, the gaps identified in section of our white paper can be closed. The other recommendation was that this major change of this landscape is going to create a lot of new ecosystem business models, so the FCC can equip themselves by likely actively participating in the industry activities such as open source communities. And the last recommendation we tried, along the same way we had discussed just before, can we come up with sort of not even a compliance or certification, but can we come up with set of requirements which can be used by vendors and service providers to validate their implementation, their product against this kind of requirement. We did discuss, and regrettably we could not get unanimity on that one recommendation. So that's where we were on this set of recommendations. The couple of items we thought could be added to the next year's work. It's a bit more, drill down a little bit more. Threshold cryptography is a fairly new one. I think Admiral Simpson raised it last time. We didn't have time to look at it. That can help a lot, perhaps in the across controllers, so SDN controller replicas and dynamic device association for SDN NFV. That's one area probably we could do some other additional work next year. And as I mentioned earlier, the open source seems to be a big driving force. So one of the topics could be how we can encourage acceleration of this development, how we manage this, how do we promote this to close the security gaps faster. So that's all our recommendation. That's in the white paper.
Now, if I heard you correctly, you still have a little bit of cleanup left on the white paper.
Yeah, actually, Dennis, I just have to mail it out. It's cleaned up. I just didn't want to send out two versions before this meeting and confuse everybody. But
okay, but we'll look for you to send that out, and then we'll, at the next TAC meeting, since it's anticipated that the cybersecurity group would be an ongoing working group.
No real content change from what we'd mailed out about a week ago. So if you want to table it, that's fine, but there's really no difference in content that's going to come next. Your call.
Yeah, I think we'll hold on this one until the next one. And with that, we're
done.
Alfine, thank you, all of you. Tremendous amount of work that's been accomplished in this area, so it's great. And the visible interaction with Admiral and his team has been really great with this group.
I'd echo that. Thank you very much for the great work, good collaboration. I think this really represents a risk reduction effort. Right. We know that SDN, we know that some of the other things we talked about are ultimately going to be deployed. And this early work that helps us better understand what is and what is not with regard to the products and the potential of the architecture that employs those products is really useful, and I think will help us achieve mutually beneficial results with earlier introduction of advanced capabilities. Yeah, thank you.
Great. On to next generation internet services. 20 minutes.
Okay, if we can get the slides up. All right, so here's the team view. I just want to thank all the great contributions throughout the year. It was a very esteemed and diverse group of technologists, and I think we had some good recommendations in the end here. So we'll get to those. Let's get lined up. So this is the charter. I'm not going to go through and read all these because I think we are a little bit behind it. Some of this is repetition. The key points here, I think everybody gets. The internet has and will continue to evolve. We'll get to some of those drivers in a minute. the real key point on this slide is what the Commission hypothesis was given to us. A best effort network is evolving towards one where quality of service is a growing concern. So based on that, some of the specific asks that the Commission asked us to comment on this year were related to really around network metrics in relation to both QoS for bias, end-to-end QoS, QoE in terms of the bias portion of the network, and then health and performance in general. Some of the other areas that we were to look at and did look at were new technology and its impact around SDN, 5G, and caching. We did realize there was some a need for collaboration because there was overlap with some of the game-changing group, and we did collaborate with them fairly well and actually handed off 5G and SDN to them. We did dive into caching. Past work we looked at were more in relation to the PSTN service transition and, of course, the Internet of Things, the scale and security and what that impact would be. As we look at this on a next-gen Internet, we're talking about 5 years out. So it's not something that's next year or the year after, but we're trying to have a 5-year-plus view. So here's a quick summary of the working group efforts. This is the exec summary slide, so we put this up front in case we do run out of time. You've got everything up front. So next-gen Internet drivers video, as we presented earlier in the year, is really, quote-unquote, eating the network. Mobility is leading the charge and the change, along with video. CDNs are strongly impacting content and Internet economics and performance. We'll dive a little deeper on that just as a recap. Data encryption is now the rule and becoming more the rule. End-to-end QoS, no differentiation without remuneration. We'll go into details on that in a little bit. QoS leverage the MBA program. We've got some very specific recommendations with regard to how to capture better QoS data. And there's 4 key areas focusing on interconnect, ISP domain, last mile, and CDN performance. And then QoE, we've begun the data, we're recommending to begin the data capture through a third party and correlate with QoS and broadband data to try to take some of the subjectivity out of it. All right, so some of the drivers, and I'm just going to hit a couple of these. Obviously, the societal changes, the expectation of connection everywhere, mobility. Then you have the Snowden effect on the encryption piece. Many devices connected per user. IoT is now driving a lot of the change with devices outnumbering people, and that will continue to evolve. A lot of the predictions, anywhere from 20 billion to 50 billion devices connected by 2020. Also, more enterprises are shifting to public internet. You're seeing pervasive services such as video, medical, et cetera. Programmability, we talked a little bit about SDN already and what that impact will be on the network. And then the real key piece we focused on these last couple quarters is really the bias becoming a critical component of end-to-end infrastructure as well as internet performance through a consumer. Okay, so this next slide, I really call it the Pac-Man slide because when you look at the growth of over 300% in between 2014 and 19, you see the video percent, and yet if you turn that red to yellow, which I didn't animate this slide, but it starts to look a little bit like Pac-Man. Also a fairly significant growth in terms of the amount of data in terms of exabytes. So just a quick view on the video piece. Another quick view, a graphic of sort of where we were yesteryear with yesterday's internet, wired access. Today's internet, wired, wireless. You've got more devices, mainly IP connectable devices, smartphones, tablets, et cetera, and starting to see the initial sort of impact of Internet of Things. Tomorrow's internet, though, it's really about connecting everything all the time. It is thing-driven, fixed mobile, wired, wireless, built-in sensors, content delivered at the metro and edge, deeper into the network. So you'll see this massive change of how things connect, what's connected, and the requirements. And we'll get to now the details. Well, one more slide on just evolutional trends. I hit some of these already. You're seeing broadband rates move up. The 314 exabytes of data per the Pac-Man slide. Then you've got the video growth, which moving to 84% by 2019. I'm looking at the right columns mainly. And the bottom bullet, 91% of all IP. Virtualization does become a critical component of the next-gen internet. And we'll talk a little bit more detail about the CDN impact on that. All right, so let's move into CDNs. So there are a small number of CDN providers that deliver the majority of internet traffic today. There was a new report that just came out today. It's not in the slides, but it was rather interesting, talking about some of the dynamics and who the top leaders are. But you're also seeing a democratization of content, i.e. the top 25 popular items are now becoming the top 75, which that requires additional CDN support, either bigger CDNs and better analytics in terms of what needs to be pushed. You also have the emergence of transparent caching by the ISP networks themselves. CDN delivery efficiencies are evolving closer to the consumer. We expect in the next 5 years, if not before, you'll start to see some of those in the consumer home even, and in devices potentially. Also provide, CDNs will move from just content or object delivery to provide increased computation. So again, the summary here is CDN strongly impact content and internet economics and performance. All right, so some of the concerns though, so CDNs have helped a lot, but some of the concerns here are the role of CDN and ISP in QoE. It's not well measured today. There's some coordination. It's not, let's just say it's not perfect coordination. CDN operators do control which server typically and what's used in the SP ingress point as well. Both ISPs and CDN content providers tend to prioritize or self-optimize based on their needs, not a combined viewpoint of that. So there's still some efforts that could take place in that role. The key point on this slide is measuring CDN performance as part of the QoS-QoE effort. We'll get to that on the recommendations. Continued concerns. Whoops, I may have not caught up there. Sorry, skipped a slide. Continued concerns. There is a problem with CDN coverage in rural areas. This may actually get worse, but there is an emerging consortia that's taking place, but also as CDNs become larger in size due to technology advances, the economics aren't as good in some of the rural areas. Key point, CDNs have greatly reduced the cost of over-the-top, but there's still this sort of tug of war between what you call broadcast delivery and over-the-top delivery. And so this is why there's not perfect coordination as well. So there's a relative cost and pricing of over-the-top versus broadcast delivery. Okay, on to encryption, and I'm moving through these fairly quickly. We covered some of these last quarter, so I'm trying to give you the quick recap, really. And this was, Milo did a lot of work on this, but you call him out a little bit. But this was our Snowden effect slide. If you take a look at what's today or what was in April and look at where we are in 2016, end of 2016, which I'm guessing that's probably conservative, you're looking at a majority of traffic being encrypted as we move forward. What are the impacts of this? It has impact to transparent caching, value-add services such as security and parental control. It does create problems for DPI-type capabilities. So network management can also be impacted. We did meet with some of the companies that do that as a service, and they're still saying they're still able to see at least the flows and capabilities. But I'd say granular viewpoints are greatly impacted. So for the FCC, the key point is assume encrypted data in all future policy decisions. That's a nice blanket statement for you guys. With that, I'd say I'm going to turn this over to John to discuss the working group's effort on QoS and QoE. These are the areas of really that we keyed in and focused on over the past quarter for the working group, and we have some significant recommendations here.
Okay, thanks, Russ. So the slide up is the definitions of QoS and quality of experience. You would think this would be the easy part, but you'd be wrong. Probably took 3 full work group sessions to come up with these abbreviated definitions. Basically, QoS typically has defined measurements and pretty accepted standard. It's an objective measurement, whereas quality of experience you can summarize by saying you're trying to measure something that is by nature subjective, which is the customer's feeling about the service that they are subscribing to. So because of that, there's been a reaction, we think, among a lot of people who look at the reality of capturing statistics and wonder if they really do translate into something that a customer would understand or have a direct impact. So this has generated a lot of the discussion. So as we looked into this, we felt like that the Measuring Broadband America program presented probably one of the best examples of how to get metrics without having to build an entire data center in West Virginia to capture all the numbers. But, Walt, we already did that, didn't we? No, it's a different story from last night. But by having this approach, you're able to go in and statistically model and have a combination of scientifically placed locations with users adopting on a volunteer opt-in basis. You're able to generate this large model that defines basically a lot of information about how it's performing. And it uses, on the fixed side, it uses what are called white boxes, which are boxes set up in the network, and firmware set up in a router at the premise location in order to be able to report on and capture the statistics for the different file types. So downside is it's in 5,500 to 6,000 homes. It is not really touching a huge part or the full part of the representative network. It covers about 80% as it is today. And generally it's measuring what's happening in the bias network more so than the full end-to-end experience. So if the goal is to get to a quality of experience, it has to be leveraged in a way that users will be able to have a more comprehensive view of what's happening. So this slide shows you specifically the types of measurements that are being captured in today's fixed Broadband America program. And you can see that it's measuring speed up and down. But the important thing is it's measuring it on a number of different file types. So you get a view for web browsing, video content, FTP, peer-to-peer, multicast, IPTV. So these things are being captured in a standardized way, and this is happening with the participation of the ISPs, with the participation of certain consumer subscribers, and it also happens with white boxes that are set just outside of the bias network at a transport network. So we'll go to the next slide. So we're trying to understand all the different aspects that were impacting this, and one of the things that came out is that the content provider, by making the decision they make on how they deliver content, actually has a lot of control on the quality that their consumer experiences. And as an example, if you're a home like many that have maybe a smart television and have a gaming system in a different room and maybe have a dedicated media player in a third room, each of those systems could be using a different CDN or a different path to deliver the content to the device. So streaming the exact same content from the same content owner by taking three separate paths could have a totally different QoS, even if your broadband link is the same across those. And that was a concept I certainly, had I thought about it before, I probably would have thought through it, but I didn't know that until that was specifically pointed out. And I think that's an important consideration, because if our focus is 100% on the bias network, then we're going to get an incomplete view of dissatisfaction at the consumer level in some of the services. So once you look at this kind of content, the other thing we want to point out is that the white boxes, which are the sort of the blue boxes that you see located at the backbone level inside the bias network and then specifically on the router in the user's home, that represents what was being measured under the current MBA. Okay? When you look at this slide, we started to talk about, well, what should be part of any metrics regime? And to state it flatly, nobody agreed. But we did document what's out there today. So on the left-hand column, you see what's in the current MBA. The center section, one of the things that came up is during the approval process for the DirecTV merger with AT&T, there were some conditions built in relative to how performance could be measured. And it's a long section. If you want to read it, you can. But we'll net it out by saying AT&T is going to engage experts in the field who will advise them on what the appropriate metrics are. But it's specifically called out packet loss and latency under load that needed to be defined. And then on the right-hand side, also as we were winding down on this, the Consumer Advisory Council made a recommendation that was being referred to as the nutrition label for broadband. And so we created a nutrition label to show basically what was being asked out of the reports and the recommendations. And it's, again, the speeds, the feeds, how much for incremental data. But then down at the bottom, it also specified availability, latency, latency at peak, patent loss, jitter, all of which I personally think are meaningless to the average consumer. So I don't know really the value of that kind of information at the consumer level. So I think there's still some work that could be done there. So when you net it out, if you're trying to build a statistical model of the entire network, well, what are some of the things that the current MBA doesn't include? Well, it doesn't include smaller providers. It doesn't really include enough interconnection points to provide the interconnection health of the overall network. It doesn't cover, like we've talked about, quality of experience really, and it doesn't measure the impact of the route that a content owner will take to deliver the content or the CDN performance. So when you start to look at that and how that maps into the next set of the recommendation, we sort of reworked this slide. We took off the content owner and put the CDN on the edge to show the different paths that are there. And so the arrows that are highlighted in green would be the types of tests that might be added to test CDN performance. And the orange or the gold arrows are the ones that would test interconnection health. And then there was a view that even within the bias, you needed to understand the performance of the bias network itself versus, or the bias domain versus the access as a specific thing. So you could divide that up into two separate things. And by enhancing this program in this way, you would begin to build a more complete model that gave a truer picture of performance and would probably more accurately represent quality of experience as you move forward.
Okay, so one key point there on the additional testing, one of the caveats that we have in our recommendations in the backup slides, it's not in the key point, but I want to bring out, we would like to see this be as automated as possible versus a new giant data request from ISPs or something like that, because that is just going to bury people. So the working group was asked to look into the comment on end-to-end QoS as well. This has been a topic that has been around for decades, I guess since really the internet was created. And the key point here is, it's a bit of a debatable topic of whether we need QoS or not from end to end and how you would measure it and what the use case is. I'm going to turn it over to Kevin, who put together a good straw man and start for this framework. This is a work in progress, and we will get to this as a potential 2016 topic as well. So, Kevin?
Okay. Thanks, Russ. Very quickly, what we're trying to do here, this isn't QoS in the something you can measure. This is QoS in something you provide in an assured way. In other words, predictable quality of experience for certain types of services. So today, of course, the world kind of splits into two things. All the things you can do over the internet and the things that are done via connectivity, which is managed typically through VPNs of various types or dedicated pipes of various types. And so both very much have their place. The managed connectivity provides the kind of quality and predictability and assurance many enterprises need, many service providers need from other service providers and things like that. So it's really and is also essential for the integrity of, let's say, a service provider's own services that they provide. But of course, that comes with a price, and so therefore, given the price of that, it's applicable to relatively high-end uses. The internet. The beauty of the internet, of course, is universal accessibility and applicability because of the low cost, the aggregate use. So there's a lot of attributes of the internet which have inspired a lot of innovation in the economy. And so the key question that emerges from all this is, as we think about the next generation internet, should the next generation internet have some mechanisms for more assured quality of service so that the line between the two could be raised and more types of things could be done with predictable QoS over the internet than can be done today. So, I don't know, you get the clicker. So if you go to the next slide, this is really to try and characterize the dilemma here, because the feeling was that it's really a fairly stark fork in the road. Today, with the current internet, that continues to scale up, gated by basically return on investment for the biased providers. And quality experience is often good for many kinds of services, but it's not always predictable. So there is a limit. And as bandwidth in biased networks goes up, but so do the uses and the resolution of the video going over it and all those other things. So they're likely to track over time. And that's the best effort world. On the other end of the spectrum is the possibility of having more of a transactional world where QoS is actually provided, but over those common pipes. But of course, this runs into the whole issue in the open internet that isn't this pay for performance, and so that's a big step to try and do something in that area that would then broaden the use of the internet or the predictable quality of experience uses of the internet. So wouldn't you like to have something in the middle, something that splits the difference between the two, that provides some QoS? The issue, of course, with all this is QoS mechanisms in aggregate flows counts on some mechanism for ensuring that the precious resource is only used, when needed and not abused. So, at the end of the day, how do you decide what users and applications get differentiated? Because if there are no constraints to that, then there really is no differentiation. Everyone has high priority, and no one has, and it's all you're back to best effort. So, it's not clear that there's really a model in the middle that exists. And I think that's going to require a fair amount more work to investigate what creative ways could be created. I'd like to point out, we've titled this end-to-end QoS, but this could apply even to just the biased network alone, pretty much, this fork in the road discussion.
All right. Thank you, Kevin. Thank you, John, for summarizing some of the QoS and QoE issues. Let's get to the recommendations, and hopefully we're still on time. There's a lot of small print on this page, but the recommendations are fairly simple, I think. Encryption, I do think they're actionable for the most part. Encryption, assume majority of data is encrypted and all future policy decisions, we said that earlier. Expand the MBA program to add QoS and QoE measurements. You may even want to change the name to the Measured Broadband Quality Program. They should be automated as possible. Also, same as MBA, open data transparency, while protecting the privacy of both the ISP and the consumer. And what I mean by the ISP networking, you're obviously going to still publish probably QoS or QoE results. Include CDN performance to the metrics measured. QoE, contract a professional consulting company to create a questionnaire to poll consumer experience data and to potentially administer the poll. The reason we're saying a third party is just probably to get better acceptance and adoption. Along that lines, though, we've got a couple of caveats. Consumer data needs to be correlated with the relevant MBA performance measurements and QoS data to develop valuable insights, i.e. what we're trying to do is get away from some of the pure subjectivity of QoE and to make sure that mitigating factors such as, what tier a person may be subscribed to if they're a gamer and they've subscribed to the lowest tier and they're having bad performance, and they rate QoE is really bad, you need to take that into account. Also, the purpose of this is to assist the FCC with future broadband considerations as well as current performance programs and consumer awareness. The other part, I know there was this Fund a Consumer Awareness program. The key point here is I think all of us have stories of helping our mothers, brothers, friends set up their network or, turn on security for once or say, hey, that 2002 router you may want to replace with a more current one. But there is a need, I think, as people look at their internet performance to have, and ISPs help to some degree already today, but I think having a more realistic program about getting education out to consumers about what are best practices in the home for networking, especially as they're connecting more and more things. Another key one is the FCC to allocate resources of data science needs to the measurement program. Currently, I think this is being contracted out and handled through partnerships, but this all becomes a data-driven exercise at the end of the day when some of these measurements on QoS and QoE are being made. And then obviously do some funded research on how to better and measure QoS as we move forward. Other than that, we did have a quick slide on 2016 recommendations. We probably want to, okay.
Have those. So
sounds good.
In the interest of time, there one quick.
Not all of these are in there, I'm realizing now.
Oh, which one do you want me to hit, Walter?
Why don't you just go through, just hit.
Okay, real quick. As Kevin pointed out, the end-to-end QoS is a work in progress and probably needs a decent amount of work, so it really depends on FCC level of interest in terms of a potential work group for 2016. Also, how to create this automated capability besides just a partnership with some of the consumer routers in the home, but how to do that at the CDN level, how to do that at the interconnect point, et cetera. The other key one, explore open source community for software-based measurements. I think there's a good opportunity there. Next-gen internet having differentiated end-to-end QoS. I think I've already hit that one. I don't know why we have that in there twice. There's a typo. How to leverage alternate sources of data. I think there is an opportunity to look at crowdsourced data or other data sources outside MBA. Again, this becomes a data-driven exercise. And then broadband bottlenecks and breakpoints, where are the limitations? And some of those could be in a consumer home. And I think the MBQ program could advise that. Another sort of unrelated activity in terms of a TAC role would be create this technology transfer program. It was after a couple of these meetings in the last week on game-changing technologies as well as next-gen internet that it became apparent that technology is changing so quickly and there's some really fast-moving areas that it may make sense for some type of scientist in residence program, and we have people like Scott on the board, but do this on a larger scale to bring in people into the FCC and maybe even vice versa. So just an option to put on the table there.
Great.
That's it.
I just wanted to just add a few comments. I will say it was a lot of good, hearty conversation, and thanks, Russ, to you and John for managing it. But I do think coming out of this with the clear definitions around QoS and QoE will provide a solid foundation going into 2016. I know many of us going into it looked at QoS as being an end-to-end, and through our discussions and awareness, we were able to drive towards, I think, a really solid consensus around QoE and the importance of looking at the end-to-end for the customer experience and the ability for how that should be measured and the outcome of it. One of the other areas I think is important to note in it is how traffic is, as I think, Russ, you said, a combined and coordinated effort between the ISPs and the CDNs to be able to provide that end-to-end perspective of the QoS and the QoE end-to-end.
Good. Thank you. Marty and then David.
With regard to the future role of the committees, most of the recommendations that we make now are based upon our view of what the Internet is today. I think there are going to be some huge changes over the coming generation, and we're going to find that education, healthcare, collaboration are going to be not only the bulk of the Internet traffic, but the most important Internet traffic. And so I would suggest that the FCC wants to understand what the nature of these changes that are going to happen, because anything that we decide now will affect future generations. And I wonder if one of the future recommendations ought to have a continuing evaluation of what the future of the Internet really is going to be. And I guess the thing that really pointed this out to me was when they start talking about making billing clear to consumers. The idea of selling consumers megabits per second sounds ridiculous to me. I don't know if it's to you guys, but I think we have all been, I hate to say bad things about the phone company when there are phone company people here, but when you go to the movies, you do not get billed when you pay for the movie by the amount of projector salary, the ticket taker's salary, and all the other elements. You pay for the experience of the movie. And when the Internet grows up, that's what we're going to be doing. We're going to be paying for specific experiences, whether it's an educational experience or the ability to collaborate with a group or a healthcare measurement. And so for us to make decisions now about the structure of the future Internet without having a feel for what it is may be premature.
Great. Good thoughts, Marty. David.
I have two comments, and they actually, relate both to this presentation but to some of the others. One is, our company, like many of the companies that are represented here, produce both open source software and proprietary software. I'm noticing a large number of recommendations being framed in terms of open source, and thereby effectively, recommending that the Commission get engaged in this sort of whole debate between open source and proprietary, which, has knock-on impacts for everybody in terms of government procurement and all sorts of other things. So I'd just like to encourage working groups to think carefully about whether or not the Commission really should be taking a position on open source or not in a given question. So in this example, for example, Russ, I think the call was really for open data, open measurement data. So if that's the call, let's push for that rather than implicitly be asking the Commission to take a position on open source versus not, especially since so many of us are in both camps. Sorry, that was one item. I'll just get the second one out and then relinquish the floor, which is I also noticed a number of the presentations here. You have a couple places with suggestions for research to be funded. The receiver presentation, I think, was just crying out for the opportunity for somebody to do research on the modeling software that would be required. I wonder if it would make sense for to gather all these together across the whole TAC here and convene a conference call with the relevant program managers at NSF and perhaps DARPA and elsewhere. And make sure these get put in front of them, because I doubt that the FCC will do it. Okay. But Russ, sorry.
And in fact, there is also a recommendation for open source versus classical software for the next round. So both of those are...
In fact, let me correct that. It's not open source versus anything, but one of the comments that came back was whether or not government should have a policy on open source.
Right.
So, and I think that's a fair question. It wasn't biased one way or the other, but just how do we incorporate or how do we view open source in terms of government software?
That's a totally fair question. What I worry about is preempting that question with a bunch of recommendations that presume an answer.
Good. Greg, and then we're going to have to close out.
I'll make this very quick. Kevin, your discussion of QoS sounded a lot to me like our discussion of harmful interference. And perhaps some of the methods that we come up with and that you come up with could be interchanged. So we could decide what's the right QoS/level of interference for each application.
I think, by the way, I think it would be the reciprocal of harmful interference.
Okay, very good. Again, a great deal of work. Good show.
To Dennis, so the proposal really isn't asking I get your point, and I agree with you very much. I have nothing against proprietary software, by the way. But as far as open source is concerned, I think the recommendation here really is focused just on trying to open up some new ideas on how to do some of the software-based measurements, because they don't really exist. It's a nascent market.
And that's what I was seeing actually in some of the recommendations coming previously too. They were really about getting the innovation out there, and I think we're all collectively probably all for that.
Oh, clicker. All right, if you could hand off the clicker to Adam Nomi, Adam's going to start.
Okay. Let me just say a couple of words, because most of this presentation will be given by Kevin and by Jack. Okay. We had a fairly broad charter. I think I wanted to thank everybody for the ideas of what technologies we should take a look at, and just make a couple of fairly simple remarks. The first one is, I think, again, taking off from Marty Cooper, this is not a static world, and in a non-static world, the mindset of the FCC should be looking forward, not looking backwards, essentially. And it's very important to understand what it means to have that mindset. That was number one. Number two, while we looked at a tremendous number of ideas, I think in the end we boiled them down to a very limited number that we were reporting on today. So the presentation for today is aimed at that. There's also a much lengthier presentation that we will turn in before the end of the year. And to have actionable recommendations, we also picked a time frame. And this is things that happen the next 5 to 7 years. I would say very surprisingly, if I look at the two topics, they're here and now. They're evolving. They're already important, but I think the impact will be somewhere downstream. So I think with those, I would say the probably last thing to say is that we had 3 working groups, sub-working groups. Brian Markwalter, who looked at demand, Jack Nishelski, who looked at capabilities, what could you do to improve bandwidth, area coverage, issues of that sort, and then Kevin, who looked at architectures. I think all these 3 things have come together. So I think with that, Kevin, if you can take it away, please.
Okay. Thanks, Adam. If we could have the future game-changing slides up. Thank you. Okay, so up front, I won't go through this for sake of time, but the working group members are listed. We had a lot of participation across the 3 work groups, plus, as was mentioned earlier, a very large number of SME sessions with industry experts on, I didn't count them up, but we must have had close to 20, 25 separate sessions, which was extremely helpful to take a very wide funnel of candidate technologies and narrow them down. The charter I'll leave as well. Of course, that's the same as it was before, and start with the executive summary. So, and actually Adam introduced this well, so I'll do this quickly, but of course, as the Next Generation Internet Group indicated, better in numbers, the traffic continues to grow at extremely high rates, and more of it is shifting over to being consumed, at least at the endpoint, wirelessly. So this is putting a lot of pressure on networks. Operators are looking at using new technologies, software-defined technologies, virtualization technologies, in order to both improve the base cost, but also very much the operational cost and the operational agility of these networks. what's really happening is that the telecom and the IT/cloud worlds are really melding and mixing together, and fundamentally going through what I think is the most fundamental transformations that I've seen in my whole career, which is only about 10 years or so. But I've been telecom since I was out of school. So the software-defined technologies and virtualization are really, and some other key ones are really the underlying enablers here. What we did, though, was to distill down and highlight two sort of uber technology areas that we felt were really bubbled up as the game-changing areas. And as we described before, programmable networks is a broad area, but basically making networks automated and so that they can be programmable is the first of these two. And then, of course, 5G is the other one. 5G incorporates many of the programmable network or SDN, NFV concepts, but applied to the wireless network. So these two are interrelated, as we'll discuss. But just to echo Adam's comment, because these changes are so sweeping, they're going to have a lot of impacts in the industry, so they're necessarily going to have a lot of impacts to the things that the FCC does and cares about. And so as we get into the recommendations, we're trying to highlight the areas in which we found, at least so far, where those impacts that we've been able to identify so far lie, and also recommendations for looking even deeper. So this is sort of just a splash of the many technologies that were considered as candidates, and we kind of broke these down into the three subgroups that Adam identified. Pretty much, in fact, there were a few more. Pretty much all of these had dedicated sessions that we held. You've also seen this before, so this is just to show, as a reminder, that we did go through a process, of course, a very rigorous process, to make a high-level assessment of these and of the key technologies that emerged, but also to acknowledge those technologies which really underlie all of this: the virtualization, the software-defined. And also an important topic between ours and the Next Generation Internet group was the use of these technologies in order to push compute and storage out to the edge of the network. So we kind of treated that as also an underlying technology. So this is this slide sort of shows the relationship or the interrelationship, if you will, between these different areas, and also the timing indications. As Adam had indicated, these while 5G schedules or timeframes are dictated by 3GPP standards process timelines, the SDN and NFV things are things that are very much underway today. But to become programmable networks, these will be built out over the next 5, 6, 7 years or so to achieve end-to-end programmable networks. Wrong direction. So for the programmable networks piece, really for the final phase of our analysis, we focused on the questions that were of most interest to the FCC related to these, because there's many different aspects that could be covered. So these 4 questions, there's kind of 2 categories: the impact on the industry, and then more specifically the impacts on the FCC. These questions are the ones that we're going to go through first between the 2 topic areas. So what change it will bring to the industry, what kinds of new business models and relationships, types of players that will emerge, and also possible displacements as well. So this is the first set of questions. Programmable networks are going to impact the industry in many different dimensions. I'm going to hit very quickly some of the key ones that will be important to the recommendations. But for operators, it will bring operational efficiency, speed of providing services, and being able to provide those services at great scale, low operational cost, and to be able to auto-adapt the network so that it operates much more efficiently. Probably even more important is the fact that this will allow services that today are at best brought into service in a semi-static or semi-automated way, will allow more full automation of services, so that these are things that can be dynamically brought up and down, scaled up and down through portals and network APIs. If we cut forward to the next slide a little bit, we're showing an example. I think we talk about this a lot, but it's good to show a little bit more graphically what this really means on the inside of a network, and what it means not only to the benefit but also the challenges. So in a SDN NFV enabled network, many of the network functions are provided as virtualized functions on general purpose computing. As we expect, some of this will be centralized as data centers are today, but very importantly also distributed out close to end users for performance and latency and efficiency reasons. The whole NFV orchestration and SDN control infrastructure will be there to control and allow programmability. Very importantly, programmability of the functionality, not just for the network operator, but also for anyone else who would like to consume those types of services on a sort of network slicing basis. But then the SDN brings the ability to also program the connectivity between all of those functions, again, for the operator, but also for third parties that would use that, and service orchestration that would essentially support the abstractions and the APIs necessary for third parties to be able to instantiate and consume these network resources. So that's kind of, in a nutshell, what the network looks like. These virtualized functions can range across the board. They can be virtual CDNs, packet cores, IMS control infrastructure, security functions. Very long list. Even some of the routing functions can be virtualized to a certain scale. So, but as for any new technology, there are also challenges. And in this area, because the impact, the changes are so broad, the standards, both standards and open source assets take time to mature, and we're definitely still in a maturing phase in all of this. Another big challenge for the operators are adapting their oftentimes hundreds or even more different operation and business support systems to work, because those are rarely ever fully replaced. As these capabilities go global, you need to be able to federate across multiple operators, and that's an area where standards need to be developed, and then best practices. And not the least of all, the skill set changes that the operators need to undertake to bring on much more IT-type skills, or a much larger percentage of IT skills. So anyway, this is the sort of a characterization of an individual operator. Most of our other examples look where we have multiple operators. One other observation, just going back for a second, is that we've seen a lot of consolidation in the industry, and a conclusion we came to here was that automating these services also tends to push industries towards greater consolidation, more winner-take-all kind of models, and you see that in a lot of other industries such as retail with Amazon, and there's many examples here. So industry consolidation is something that this is likely to advance over time. On the other hand, these new technologies open up the possibility for greenfield entrants to come in as well, maybe cherry-picking a subset of applications, data center interconnect, for instance, things, enterprise connectivity, areas that benefit most from having dynamic on-demand service capabilities. In terms of the sort of ecosystem effect of all of this, again, this is an area that may have a significant impact for the FCC in the sense that rather than a fixed, fairly static number of service providers, very sort of predictable model, this is likely to disaggregate into a model where you have a lot of virtual network operators, many different types of virtual network operators, maybe some new entrants. Some of these may be sort of coming up, expanding geographically, growing, shrinking, a lot of dynamics here. So that is a more complicated ecosystem, if you will, for the FCC to deal with. But it also opens up new innovation opportunities for new kinds of applications that maybe aren't possible today. Low latency or very high bandwidth services that would be not efficient enough, couldn't be implemented efficiently enough with today's network implementations, but in the future will, and a bit more on that in a moment. The next example is just showing a virtual network operator, and for the sake of time, I won't go into this very far, other than to note that this opens up this is sort of an illustration showing the possibility of a many-to-many kind of two-sided business model, where a various vertical service provider, in this case a fleet management and tracking type of company, could work with many different end enterprises to provide them services, but also with many different network operators in order to have the geographic reach and maybe redundancy that may be necessary. And their ability, the key thing here is the ability to be able to instantiate a functionality like IoT gateways, even packet cores that are customized for that particular vertical's application or for that particular vertical's business. And you can imagine there's almost an unlimited number of different possibilities for this kind of shared value chain going forward. Went ahead too. An aspect of this that we wanted to call out separately, but it's part of programmable networks, is the distribution of edge and compute capabilities. This is very much enabled by having the virtualization and SDN capabilities, which allow for many different kinds of functions to be instantiated in even a very small size very efficiently. And so you can distribute a lot more things out close to the edge of the network than you could within the current, sort of appliance-based and chassis-based networks of today. So what does this open up? The possibility for more efficient distributed content distribution. There are many CDNs today. Distribution is happening. More distribution can be done where these functions are being able to be implemented in a virtual way. These low latency apps that I mentioned before, you can think of augmented reality applications as a leading example of the kinds of things that may only be possible, some of them with this kind of few or even single millisecond kind of delay times. But also, it's like CDNs in reverse is IoT applications using very high resolution video sensors and using functionality in the network to be able to, again, take all of this data and reduce it to the critical set of information very efficiently, rather than dragging all that capacity back over the internet, which may not be feasible or affordable. there's another example here I won't walk through. I'll leave it for others to see of just that type of application. So think, CDNs downstream and video content processing upstream. These are kind of prime examples for edge cloud applications. So with that, I'm going to turn it over to Jack to cover the 5G questions in this set. Oh, sorry, you don't have a mic.
Okay, great. Thanks very much, Kevin. So we looked at similar questions for 5G, and of course this is something we do every 10 years in the mobile industry. It's time for another G, so we're gonna do it. So what are the new opportunities that 5G is going to provide? It's not just about the technology, it's about how the industry is going to change, what types of new players, what might emerge. Kevin mentioned a few things in his talk about maybe more virtual operators and that sort of thing. What kind of displacements are likely or possible? Let me just go through some of the potential answers to these questions. So as I mentioned, the industry is geared up to do 5G. The last 2 years basically have been an effort across the world, really, in Asia, Europe, the U.S., companies that are in this industry trying to decide what the key use cases and requirements are going to be for 5G. So the picture you most often see, I should have included it here, is basically improvements on every dimension that the mobile networks currently have. So it's throughput, coverage, capacity, it's lower latency, it's lower cost, it's everything that you can improve. Let's see if we can do it in 5G. What we're actually settling on in terms of major categories, if you read any of the white papers that have come out, or you look at the ITU IMT 2020 sort of overview and so forth, it's really three big topics. It's enhancing the current mobile broadband service. It's connecting billions of things with massive IoT services, and it's mission-critical applications. And what that means is better reliability, lower latency, the ability to do things with the mobile network that you really can't do currently with 3G or 4G networks. We'll talk in a couple slides about the spectrum picture that's emerging for 5G, but it's very broad. It's from a few hundred megahertz to almost 100 gigahertz that is currently being looked at. The FCC obviously has already taken some actions on 5G, and that'll continue over the next couple of years, we expect. The key point here is that the system's designed from scratch to handle this very diverse spectrum, and it includes everything from pure licensed spectrum to shared spectrum to purely unlicensed spectrum. Capacity, efficiency, scalability are some of the key design considerations in 5G. We'll talk a bit about some of these scalability questions. One of those is spectrum, obviously. And then as 5G is deployed, obviously when it starts, it'll be kind of spotty coverage. You'll have to consider multi-connectivity between the existing systems that are there today, chiefly Wi-Fi and 4G. How do we make sure that devices are always best connected? Okay. So again, a few more points on how it changes the industry. It's really an end-to-end transformation of the network. It's not just a new radio access. So taking into account some of the more recent developments in networking, the programmable networks, as Kevin mentioned, is sort of a assumption that the 5G system will be designed using these kinds of tools. The radio interface itself is mostly unconstrained by the previous designs. It's maybe not a complete clean sheet of paper, but you don't need to have backwards compatibility as you do with the different versions of LTE and Wi-Fi as you go forward. It's going to have its own waveform with a flexible framework to handle these requirements at scale and different dimensions. Key points that seem to be emerging so far: massive MIMO, very much better spectral efficiency with the ability to have spatial diversity with beamforming and so forth. Different use cases where you don't just have an access point and UEs connected to it. You've got possibly mesh networking over nodes that support both access and backhaul, so you won't need as many fixed backhaul points if you can do some wireless backhaul to get everything connected. As Kevin mentioned already, the standardization has started in 3GPP. Already since the beginning of this year, they've been working on requirements, and there was a RAN workshop just in September to start the radio design. So there's a couple of releases in 3GPP scheduled in sort of 2017, 2018, with deployments of the technology expected around 2020 for the standard compliant 3GPP versions of 5G. Okay, this next one is really 3 slides crammed into one, so I'll go left to right. The first picture is just showing the 5G unified air interface that has to support, again, the diversity and spectrum, the different types of services and devices, and then different types of deployments. So this challenge for the designers of this air interface will be to have waveforms that scale to support all these different requirements and deployment models. It's an interesting topic to be working on. And then the multi-connectivity framework, as I mentioned, you're going to want to think from the beginning about how to connect Wi-Fi, 3G, 4G, 5G to get the best experience for whatever application you're trying to run. Also, potentially to aggregate the connections across these different technologies to give better throughput and performance and so forth. And then on the network architecture piece, we're considering a lot of things here. In addition to how this technology gets deployed, also how the business models and subscription models can evolve over time. We're looking at the 3 to 5 year time frame. If you consider where smartphones were 5 years ago and you look at where we are today, we're adding all these new device types. We'd like to see if we can get some new ideas in there for example, for getting devices connected to networks more efficiently and quickly, and working with operators to maintain the security that the networks currently have, but also give better flexibility for managing these billions of devices that we expect to connect to the system. Okay, so millimeter wave and how to mobilize this technology is a major challenge for 5G. You're going to see very large bandwidths, hundreds of megahertz in the channels being used, multi-gigabit per second data rates, the flexibility in deployments, as I mentioned, with integrating access and backhaul, for example, very high capacity with dense reuse of the spectrum in space using like new antenna technologies like beamforming and beam tracking. To the challenge, obviously, is the robustness, because you've got very high path loss and the link can be blocked easily. How to get a handle on the cost, power, and RF challenges at the frequencies we're talking about here. So one other idea is tightly interworking both the millimeter wave and the sub-6 gigahertz links to preserve a good experience for the device, and overall optimizing the design of millimeter wave for mobile applications. This next slide is all about the spectrum assets for 5G. It's a little bit difficult to read this one potentially, but let me just walk through it. As I mentioned, the range of spectrum is extremely wide. The assets that would be addressable for 5G need to balance the coverage and capacity requirements to meet the demand that we see emerging. So some of the technologies I already mentioned, the scalable OFDM for frequency and bandwidth flexibility, adaptive beamforming and beam steering, and interference reduction and improved SNR. So to try to carve this up into different chunks, sub 6 gigahertz is basically capacity and coverage. And you've already seen, again, the FCC action talking about a coverage layer for 5G, which is good. In the next chunk, sort of 6 to 20 gigahertz, you can still get outdoor to indoor coverage with that. That's a crucial area for 5G. And then at higher frequencies, you're looking at smaller cells, dense deployment, very highly targeted capacity with very wide channels, again, that would be available there. Okay, we also, in our meetings in the capacity group, we had a couple of presentations from satellite companies or people looking at doing some creative things with satellite, and that's an area that the FCC should not lose sight of, both for fixed satellite services and the capacity and economics of those are getting better year after year. The new satellites that are being launched are orders of magnitude better in terms of the throughput that they're able to provide. The non-geostationary satellite capacity is also increasing, and you're seeing some creative ideas there and possibly new constellations being deployed and so forth. So the key advantage, obviously, of satellite is you get this coverage very broadly for rural areas. The issue always for satellite, though, is latency. So there's some consideration of designing a hybrid network that has both an LTE component or a 4G, 5G component and a satellite coverage component. So the combination of that idea plus the programmable networks could provide some interesting capabilities in the future. So the recommendation here is really just the FCC should try not to hinder satellite as a alternative or a part of the overall solution for broadband. And at this point, I think I'm going to hand it back to Kevin to talk about what the FCC ought to do with all this.
All right, thanks, Jack. So this next section I'm going to skip over because I think between what we covered before and the recommendations,
For our time interest, that's enormously helpful.
Yes, I knew that would be the case. So we're going to jump to the recommendations. You won't miss much, but it's in there for you to take a look through. So in terms of recommendations, we have some specific ones and then some broad general ones. Starting with programmable networks, the wording here is the FCC would greatly benefit, although we had stronger wording in here at one point. The belief is that SDN, NFV, building up the programmable networks, that this is going to have such profound impacts to the industry that it's an area that the FCC needs to ramp up expertise, both sort of technical but also business understanding in this area to make sure that, frankly, that the U.S. Remains technology leader and is competitive in a service provider sense. leaders in the world in this area to maximize the amount of economic benefit that will come from this. So I mean that's kind of putting it in a large context, but I really think that's true. I mean, when I contrast these two topics, 5G is an area that the FCC, of course, is going to be all over. Certainly the RAN parts of 5G, it's a natural, it's in your wheelhouse for sure. Programmable networks, which you could think of as the 5G core, but also the wireline networks and all of that, oftentimes, affects not as directly the internet piece of it, though it impacts that, but it impacts a lot of the other sort of managed services and managed and network resources that can be used by enterprises and service providers, things like that. All of this space and the fact that new types of virtual operators and new kinds of operators are likely to pop up. I think we can't make the recommendation strong enough that the FCC really needs to ramp up on this area, because coming from within the telecom industry, these technologies are permeating everything that's being done. So what can the FCC do specifically? Because the rules and procedures and policies that are there currently were set up under today's much more static, stable world. It's pretty clear there's a lot of things which probably move too slowly in terms of enabling new operators to or new virtual operators to come into into service and set things up. Responsibilities between different parts in a shared value chain type scenario, and so we think that really the dynamics of how FCC processes and rules and policies operate need to be looked at very closely. With this in mind, these fully programmable networks, they're a few years out, but the early instances of them are operational in production capabilities today. We have on-demand services being rolled out by some of the large providers. Also, we think that these technologies, as most technologies do, will get rolled out for the high-value, high-density areas first, most likely. But they hold out a lot of potential as well for the less well-served areas. So we think this is also an area that needs more focus in terms of looking for how these, particularly virtualization, allows for very small instantiations of functions. So advanced functionality could be deployed in areas that in the appliance and chassis world maybe it just wouldn't be viable. If we look then to kind of the 5G and satellite specific recommendations, here it's a lot about making sure that there's freedom for everyone to pursue kind of an all-in spectrum strategy, but also very importantly being able to combine different types of different spectrum, but also different kinds of spectrum, licensed, unlicensed, shared, to be able to combine those in intelligent ways, because you can get much greater overall utility out of them if they're not just used as sort of individual silos. That's probably going to bear on spectrum policy going forward. And so that's a ripe area to look at. So basically, looking to avoid spectrum policy barriers, if you will, to allowing both the flexibility and the high utilization associated with that these more flexible technologies are enabling. We mentioned, Jack talked a little bit about the satellite area. I think it's fair to say whenever you look at both the sort of capacity and coverage aspects of things, the capacity gets the first attention, 85% of the attention. So as you'll see, we're recommending maybe going forward that there might be a dedicated effort looking more at coverage issues and new technologies, because I know we didn't focus enough time on probably the coverage aspects, but we did look at hybrid use of satellite and cellular, or satellite and other forms of access as promising areas to bring sort of balanced capabilities, high capacity and also low latency in the right mix to rural areas. So in terms of the overall recommendations, we really broke these out into four areas, some of which you've covered, so I'll only highlight a few additional things here.
And do so quickly, please.
Yes. So obviously awareness and expertise, we've already talked about that, so there's some specific recommendations here. Maintaining, monitoring global activities in this space, doing an analysis, sort of a hot list of emerging technologies, doing this on more of a rotating basis, things like that. But the first and foremost recommendation here is the building up the expertise on both the technical and the business side. The FCC policy and process agility, I already spoke to that, but very important. These are the ways, in a way, these two are the FCC understanding what's coming and then adapting to what's coming. If I go to the final recommendation slide, these two areas, encouraging innovation is very much about trying to encourage the kinds of ecosystems which these shared value ecosystems and things like that. So this may require creative adjustments to the way the FCC operates in order to sort of not block new things because of old rules. And so our recommendation here is to very explicitly kind of review both past and going forward policy activities with these technologies very explicitly in mind. And then finally, for the rural and underserved area, one specific recommendation in that area, I think it was captured in the earlier slides that I didn't cover, was the idea that perhaps using sort of universal service type funds, things like that, to help catalyze deployment of sort of edge cloud technologies in rural areas, which would allow advanced technologies to roll out to those areas much faster than they would otherwise. So we also have a list of suggestions for next year's TAC, which you've already captured,
I think we'll just
probably.
grab those and
Yep.
run, and we are running tremendously over time, I'm sorry to say. The topic is so fascinating and interesting, and the good work that's been done is hard to cut things off, but we do need to continue on. So let's move to the next, which is the future of unlicensed services, with thanks to the team, to Jack and Kevin, and to Nomi, and to Adam.
Okay. All right.
And anything you can do to...
I will. I have already been cutting down things here.
Okay.
Sorry. Okay. So I'm going to do my best to get the meeting back on time.
That's not possible. But
Okay, I will do my best. Okay.
But what you can do to try would be great.
Okay. All right. Well, this is the Roadmap to Unlicensed Services Working Group. Chair, myself, and Millen Bluka, sorry, and Vice Chair John Brahill. Now, the FCC liaisons have been very helpful, Michael Ha. And I also want to mention, not listed on this particular slide here, is Karen Rackley, the FCC Part 15. She's been tremendous help. Okay. The next slide is a... Oh, sorry. I'm sorry. Okay, the next slide is the list of members. I'm not going to read the list of members' names. Okay. Our opening statement, unlicensed services, have played an unexpected vital role in the evolution of communications capabilities and in providing a wireless commons for innovation. It is critically important for the Commission to understand both the potential pathways for continued evolution of unlicensed services as well as the potential threats to the continued viability of the commons. Okay. The work group focus was evolving novel applications, i.e. low-powered WANs, Internet of Things, unlicensed LTE. Second was new business models. The third was candidate for spectrum bands for increased availability of spectrum. For voluntary adequates and unlicensed service applications that will help protect the commons model. And 5, potential impact of EMC limits for consumer and industry devices. Okay. All right. The growth in the GDP numbers of unlicensed spectrum on our annual economic growth are a great example of how unlicensed spectrum and the FCC's Part 15 rules have created an amazing environment for innovation. As you look, the total number of the economic to the U.S. is $220 billion, $62 billion of annual retail sales in Wi-Fi devices. And we've seen an increase of 48% of the total traffic over Wi-Fi, up from 48% by 2019, up from this. That's the total IP traffic. The mobile originated IP traffic over Wi-Fi is at 57%. So that's more than what's going over to licensed networks now, and it should be to 66% by 2019. And the percentage of VoIP traffic over Wi-Fi versus LTE by 2018 will be 53% on the average. We're starting to see new entrants into this market with unlicensed LTE, and for the first time we're starting to see new entrants that are coming in that are VO Wi-Fi first, which are default over Wi-Fi by voice, and then they're roaming to NVNO when Wi-Fi isn't available. 56% of the voice traffic is currently carried over unlicensed spectrum now for mobile. And one carrier that we talked to was already at 10 million calls per month over unlicensed. Other services, because of data offload, are going to be continually increasing. Okay. This slide shows the over the time scale of how the rules have come in on unlicensed spectrum, to where the work groups have come in and have released Bluetooth 802.11b, 11a, and the growth that this has led to. I'll give you a little example of how things are moving. All right. The National Broadband Plan, to achieve this goal through an executive presidential memorandum, they have asked for 500 megahertz of spectrum to be available by 2020. Benchmark of 300 megahertz of spectrum available by 2015. Currently, we're at 245 megahertz. I guess it isn't quite over in 2015. In addition, we should ensure greater transparency in spectrum allocation utilization. Although unlicensed spectrum is mentioned in the presidential memorandum, there is no requirements of what percentage of this 500 megahertz of spectrum should be provided to unlicensed. So that's, and of course, if you look at the economic development growth, that I would like the idea of more unlicensed. All right, this is the current unlicensed spectrum auction summary, showing how we're leading toward that 500 megahertz goal. I've included the 3.5 gigahertz, even though it's unlicensed by rule. It's licensed by rule, but it falls into it. Okay, I will quickly get past that one. Okay. This chart shows both the current megahertz of spectrum in the pipeline for unlicensed spectrum, and in a reference on the top, you'll see that I've included the FCC compared to the European unlicensed spectrum allocations. And if you add things up, we'll be close to going through. And currently, an additional 7 gigahertz is available at the 60 gigahertz band. Plus, there are other bands that are spread out through the unlicensed that can be utilized through sharing. All right. And this slide was included to show the demand cycle growth of unlicensed spectrum capacity. The growth of unlicensed spectrum devices and applications and capacity demand continues to grow at an expanding rate. The limit of this growth, the final limiting factor of this growth will be the capacity of unlicensed spectrum. Okay. All right, here, the industry engagements, we reached out to the following people. We reached out to Verizon, T-Mobile, Sprint, associations and artists, Wi-Fi Alliance, WISPA, equipment manufacturers of Qualcomm and Ubiquiti, and standard bodies of IEEE 802.15. And the key observations from the industry reviews, primarily, more spectrum is needed in licensed and unlicensed band. Continued light regulation is preferred. Lot of discussion over oversubscribed bands, such as the 900 and 2.4, with concerns about the 5 gigahertz band. There were mentions of life essential services emerging using unlicensed spectrum, such as IE traffic control, SCADA systems. Okay. On increasing demand in 5 gig services, there was a large discussion on this. Spectrum will be shared by both Wi-Fi and LTE variants. Agreements and mechanisms are needed to ensure fair coexistence. Industry groups are engaging with each other and the FCC to resolve any possible conflicts. And interesting parties responding to the Commission ET 15501. And in the working group, we've decided to defer any specific technical recommendations on ULTE since it's an open proceeding. Although it was one of the major topics that were brought up in any discussion with anyone, and it's completely left and right. So the Commission has got its work cut out. There's no doubt about that. Okay. All right. Okay. The carrier Wi-Fi grows in primary use case. Another growing use of unlicensed is the moving of what were primarily provided over licensed wireless services are quickly moving and expanding into unlicensed spectrum. Wireless services. I got to go back. Sorry. I should let you run the clicker. How did I get that far? Sorry.
I'm impressed at how quickly you were getting to.
Yes, I'm sorry about that. Yeah, I was really moving. Yes. Okay. Currently, service providers are complementing data and licensed voice with voice over Wi-Fi and using unlicensed spectrum for offloading as much broadband from 4G to Wi-Fi as feasible. Wi-Fi first voice providers engaging in default are moving quickly. Now, okay, let's see. Okay. All right, and this obviously is increasing in demand for wireless spectrum. Okay. Factors evaluated. Of course, more unlicensed spectrum and more effective use of available spectrum in managing interference. Some of the concerns were the increase of high constant use of spectrum, such as airborne UAVs that use constant video channels for transmission, and control links that were at heights that the transmitters would provide large areas of interference potentials. Let's see, rogue APs, smart meters were some of the things that were brought up, and that might introduce potentials. And of course, the future of, i.e. abandoned IoT transmitters that may pollute spectrum. And of course, the coexistence between competing technologies between ULTE and Wi-Fi. It's always brought up. Okay. This slide shows the congestion. Of course, more spectrum, but better unlicensed utilization. Licensed spectrum, due to the high price tag of licensed spectrum, has been more cost-effective for developing and spending money for spectral efficiency. We're starting to see that unlicensed LTE technologies are moving to unlicensed technology. One suggestion came up that speeding up the use of LTE and other advanced spectral efficiency protocols could be done by removing some of the requirements for license base frequency tied to LTE. That was one suggestion that came from one group. It's not an industry. It's not the committee making things. It's just a. Okay. Okay. Avoiding congestion, improving utilization. All right. This one, likely performance indicators, indoor versus outdoor, long range versus short range, wide and narrow band, heavy duty cycle, low duty cycle, apps that can perform under interference conditions that may not be suitable for bands, such as life critical services, traffic systems, utility services, high duty cycle, wide bandwidth, medium range, and as under the Part 15, everyone has the same right to transmit as long as each transmitter solves it. Okay, and the unlicensed band cannot interfere with any licensed band, as we know. They must accept interference. Currently, this has worked very well, and the industry standards have often balanced the spectral efficiency to capital efficiency for a given app, but not usually for cross applications. Okay. All right. Consideration to avoiding congestion. Here are some suggestions that were brought up in discussion, but the concerns about the TAC meeting moving on time. TAC moving on time. We'll move to the recommendations. Okay. All right. Part 15. The creation of flexible rules of Part 15 allowed for the growth and proliferation of unlicensed devices. Oh, shoot. Sorry. Thank you. Thank you. Expanding opportunities for innovation, spectrum access models, as listed in page 94 of the Connecting American National Broadband Plan. The consensus between rules and certification testing. We believe that additional Part 15 rules are unnecessary at this time. However, technology changes and are constant. That the Commission should constantly continue to monitor the situation. All right, recommendation number 1, evaluate bands between 6 gigahertz and 52 gigahertz to address the demand for unlicensed spectrum. Propose initially 1 gigahertz of spectrum for exclusively shared, unlicensed to bridge the benefits of propagation characteristics between 5 gigahertz and 60 gigahertz bands. Accelerate proceedings to release the 7 gigahertz of additional bandwidth above 64 gigahertz for unlicensed spectrum. Okay, and recommendation 2, promote spectrum sharing between licensed bands when evaluating candidate bands. Commission and NTIA should consider unlicensed applications and encourage other agencies to add this consideration to all future spectrum studies. Identify specific bands for studying, including FSS, Earth to Space, FS, AMT, ESS, SR, and RAS, and others. Identify restrictions, i.e. low power, geographical restrictions that could potentially increase shared bandwidth. Consider initial deployment of controlled usage with database-like approaches similar to the 3.5. And go back one? Okay, sorry. Okay. Recommendation 3, consider rules to improve spectral efficiency as new and shared unlicensed bands are released while retaining flexibility. Include physical layer characteristic protocols for interface mitigation and overall performance. These concepts and questions to be included during the future unlicensed bands and rulemaking procedures. Encourage an industry-led effort to develop a best practice guide for unlicensed operation for current and new applications, similar to licensed public safety bands. There are already bans for wireless communications groups like NTIA have put out groups, and so public safety, but there isn't one for the wireless groups. No. Once proven to be effective, consider applicability to extend unlicensed bands to existing. Okay. And recommendation number 4, promote industry-given coexistence across various standards and unlicensed bands. Coexistence, existing models have worked well. Simple technical rules and reliance on industry standard bodies to promote the efficiency and use of coexistence have worked quite well. As bands get more crowded, coexistence among various standards can provide more efficient use. Okay. And that's it. Thank you. And did I make it? Yes, I did.
It's a lot, and it is terrific. Kudos to yet another working group. Done a great deal of work through the period. Not seeing anyone jumping up and putting up their tent cards, we will move on sprightly. Oh.
So there's a comment made that high-duty cycle, wide bandwidth, and medium to long range will create likely sharing challenges. So what should be done to discourage those kinds of applications in these bands?
Well, as far as rulemaking goes, no one wants any rulemaking in the Part 15 anyway, so there's no rules. Currently, what's happened so far is in the unlicensed bands, applications typically that, whichever the most popular applications have driven models to control the model. It's been sort of a self-regulating operation so far. One of the early entrants into unlicensed spectrums were basically analog video. Cameras were but those cameras completely made Wi-Fi and other types of applications completely unusable within the regions. Then, as demand for people wanting the new technology and Wi-Fi, people started basically turning off their 2.4 and their 5 gigahertz analog video cameras. So it's sort of driven by demand now. So it just that currently that's how it goes because everything's an open wild west in the Part 15. But it has so far, and as we've gotten from almost everyone in the industry, they both want protection. They're very worried about it, and they want to make sure that everything works. But at the same time, they want no regulations whatsoever. So this is a. So to answer your question, as long as it's still working, there's nothing. They're not asking for anything.
Okay, very good. Let's move then to mobile device theft prevention. And since you've already had a practice round with the chairman, I'm sure this will go quick. And if it is possible, which is going to be very hard, if you could do this in 20 minutes, name that tune in 20 minutes, that would be enormously appreciated.
It's going to be a problem. Slides?
Yeah. Okay, this is the report out of the Mobile Device Theft Prevention Working Group, and I'm going to jump through this very quickly, but I do want to stop on the participants and again acknowledge that we had quite a few participants, quite a bit of input, and of course Rob, my co-chair, don't want to leave here without acknowledging all the effort he put in. The mission statement obviously hasn't changed, to look at ways to combat mobile device theft prevention and provide recommendations that we can use to combat this topic. Earlier this year, we were given 3 specific tasks, one looking at on-device theft prevention techniques, second one looking at hardening device identifiers, and the third looking at the database issue. Both tasks, 1 and 2, we did provide an interim report back in May, and we do have a final update today. And task 3, we do have the final report as part of our presentation today as well. I'll go through this one real quickly. The on-device theft prevention features, as I reported in September, CTIA was looking at updating the voluntary commitment with the manufacturers and service providers to take some further action on addressing the opt-out functionality and other working group recommendations. In October, the CTIA and the signatories to that voluntary commitment did come out with an update to Section B, Part 1, which promotes the widest possible adoption of anti-theft tools while respecting the importance of consumer choice and privacy. In addition, CTIA developed a list of apps to locate, erase, and or lock, many of which are free for the various operating systems, and created step-by-step video instructions on how to set up a PIN and password on the various mobile devices. I won't go through the chairman's statement, but suffice to say that these solutions only work if they are adopted widely, and continued emphasis on this approaches are needed. There are basically two types of anti-theft, on-device anti-theft features that were looked at and examined by the group. The first was the passive background feature like reset protection, activation lock, reactivation lock, on-device passcode and encryption, and these are enabled at device activation by the authorized user. The second set of anti-theft features are tools such as remote lock and erase and require additional user action after the device is lost or stolen in order to be triggered. And some mechanisms include going to a website to activate that action. As you recall, one of our deliverables was to develop a comparison of anti-theft tools, taking into account what the language in the CTIA commitment specifies, along with the California and Minnesota laws that have been passed with regard to this topic. And as a result of that, we took a detailed look at those three inputs and the various capabilities and came up with a working group view on those various topics. And that working group view appears in the right-hand column. We'll get back to this later when we look at the recommendations, because we do have a recommendation around this. Also associated with Task 1 was the GSM Association has been looking at anti-theft device feature requirements as well. They published a version of their requirements document back in May of last year. However, they are continuing to look at it based on the work that we're doing here within the FCC TAC, and they expect further updates on the anti-theft device feature requirements expected in early 2016. And as shown on this slide, many of the features that they're looking at are consistent with what was on the previous table as part of the features that we're promoting as part of the on-device anti-theft tools. The conclusions from this analysis is the industry has invested significant resources and effort to develop these mechanisms to help smartphone owners reduce the impact on the theft and assist in the recovery if they fall victim. We've noted the United States has led the world in seeking device-based solutions and initiatives such as what we're doing here within the TAC, as well as the voluntary commitments from wireless service providers and device manufacturers and OS vendors. We've seen that this leadership role has really taken note and effect in combating this overall issue. As the laws have been passed in California and Minnesota and the CTIA voluntary commitment has been established, we expect to see an increase in the take-up on these capabilities and anti-theft features on the smartphones over the coming months. Analyzing the trends in consumer usage and obtaining an understanding of consumer usage patterns will provide us with a data-driven basis for determining whether any future action is required to increase the consumer usage and adoption of these features. And in doing so, additional remedial efforts can be targeted to identify deficiencies. The next area we looked at was hardening of the IMEI, and through the GSM Association, this is one topic that has been taken up and identified as one of the priority areas that need to be investigated. Both the North American Regional Interest Group of the GSM Association as well as the Global Device Security Group have been looking at this topic. The effectiveness of device blocking on mobile networks is really dependent upon the secure implementation of device identifiers. And mobile technology standards that provide the identifiers have to be unique per device, and they must protect against alteration after the point of manufacture, although there are no details or guidance on how those security goals are to be achieved. There's significant efforts were made to improve the device identifier security, and there's been commitment and engagement by the device manufacturer community. And the industry has concluded that standardization is unsuitable as a means to deal with the device identity issues, because incorporating the enhanced security issues into standards could be problematic and undesirable. Basically, you're giving away the tools that you're using to protect it, and you may not want the bad guys to know what those tools are. The GSM Association has two major industry initiatives designed to enhance security of mobile device implementations. These were introduced in 2011, and 21 of the largest device manufacturers signed up to support both initiatives. As a result of that, it was noted that the number of devices with vulnerable identities decreased by 77%, the number of manufacturers with vulnerable products reduced by 45% from 11 to 6, and the available and effective hacking tool showed a 72% decrease. It is noted that there are problems with two manufacturers that accounted for 83% of the compromised mobile devices, and the failure for them to respond appropriately to reported security problems was regrettable. Also pointed out that mobile device modification of device identifiers is a criminal offense in some jurisdictions, but not here in the United States, and we'll see a recommendation around this. Websites and outlets do exist and are on the increase that openly advertise the ability to change device identifiers. And the developers of attacks against these identifiers are known to be based in the U.S., Israel, India, and Eastern Europe. As I reported in the September meeting, ATIS has been working on and has concluded and published best practices for obtaining mobile device identifiers. This will assist law enforcement in coming up with a standardized approach where they can obtain the mobile device identifier for use and look up to see if that device has been blacklisted. Won't go into the details here, but they've covered various cases, including when the device is locked. The third task is database, and this is probably the biggest task that the group worked on this year. We looked at various use cases surrounding law enforcement, consumer, and resellers of secondhand devices, and how a database solution would benefit each of those use cases. The database solutions really can be categorized into a number of categories. Those used by network operators containing the device identifiers, which are used to deny access to stolen devices on their networks. A global database provided by the GSM Association to share and distribute the device identifiers among network operators, not only here within the U.S., but on a global basis. Some OEM and OS vendor databases which specify the enrollment status of the on-device theft prevention solution, and an aggregator database which provides device checking service and or portals to network operator and OEM databases. The North American Regional Interest Group, as I mentioned in the September meeting, I won't go through this again, but there's various technologies that can be used on operator networks to make use of the database information for blocking those devices on their networks. The next two slides, again, I won't go through these. I think I showed these in September, but this just highlights how those technologies can be used for blocking the devices, and this one goes into how the GSM Association database can be used, for example, for sharing across mobile operators. As far as the conclusions from database, they're really a number that we came to conclusion on. One is law enforcement related, and primarily there's a lot of education that needs to be done in this area. Law enforcement officers may not be aware of the significance or the existence of device identifiers, or what they can do with those device identifiers once they have access to them. As I mentioned, the ATIS standards will help with defining the procedures to obtain the device identifier. So as the situation today is, it will vary among different manufacturers, complicating the law enforcement abilities to acquire the necessary information. On the consumer-related side, there's a fragmented system of consumer outreach which exists. There's no single government agency, group, or manufacturer or carrier that provides a uniform and comprehensive outreach program or source of information. An important note is that consumers don't always report the theft of their devices to law enforcement and or the carriers. So there's still the lack of information coming from the consumer side that needs to be further addressed through consumer outreach. And finally, potential buyers of smartphones don't have access to the complete information to verify that that device is not a stolen device. We also found that mobile device information is dispersed across different stakeholder databases, and this includes the blacklist, either globally or locally, insurance databases, OEM device check services, and so forth. And a lookup across more than one database is required currently to get comprehensive information. There's also timeliness of the information, which is too long and dependent upon the reporting frequency as well as the upload and download frequencies of most of the databases. And there is efforts underway within the GSM Association to harmonize the practices and policies of blacklisting of the blacklisting devices. It's noted that many mobile network operators in other countries do not block stolen devices or share relevant data with other operators. Thus, many smartphones in those countries could still be operational. And some U.S. mobile network operators, especially the smaller ones, don't block or report their devices as stolen either. The solution we're proposing is a device information portal, and what this does is allow three classes of users: consumers, law enforcement, and commercial, to gain access to information so that they can make intelligent decisions about the device that they have or find information about the device that may be lost or stolen. There's a number of characteristics, and again, I won't go through each of the characteristics of the portal, but suffice to say that the information that is entered into the portal, such as the device identifier, you'll get information back based upon what level of information your particular request will dictate. If you're a consumer, you'll just get back basic information about the device. If you're law enforcement, you'll get more comprehensive information that's available. So finally, moving to the working group recommendations, we have 13 total recommendations that we are proposing this year. The first is CTIA, along with the GSM Association, on behalf of the industry, to implement the device information portal based on the objectives contained in our report that we're asking for approval today. The second is CTIA, who has done studies in the past on researching consumer usage and trends for smartphone security. We're asking them to again take the task before July of next year to update their study and research to see how the trends are going. The third is recommending the FCC to work on developing effective outreach initiatives to educate the consumer. For example, create a website consumer educational portal and outreach program to inform users about anti-theft initiatives. The next is to take a deeper investigation by industry to try to come up with the causal factors for the increase in consumer use of mobile device theft prevention functions that could be used to determine how to optimize further efforts to incentivize greater consumer use of those features. We also recommend an industry-led investigation into whether the increased availability of the anti-theft functionality on new smartphones, as well as the upcoming initial device setup prompts that are required under the California legislation, have any effect on increasing consumer use of these features. We also recommend that ADIS, working with other key stakeholders such as the GSM Association, identify key technological areas where the FCC should seek further information from industry, and that would be including but not limited to the IMEI requirements and use of databases and future theft prevention opportunities. Next, the FCC TAC recommends the industry adoption of the voluntary framework for a set of on-device capabilities to guide industry based on the working group view of that chart that I presented earlier. So we're looking for the industry adoption of essentially the capabilities for those on-device features and asking that CTIA maintain a publicly available list of OEMs and OS providers and carriers reflecting the CTIA smartphone voluntary commitment and voluntary support of the working group view in that table presented earlier. As mentioned, the GSM Association is working on a best practices implementation guideline for device blacklisting, device blocking, and data sharing, and we recommend completion of that best practices. Also, we recommend the GSM Association, working with the mobile device manufacturing community, review the published technical design principles that they have in place to ensure that they remain relevant and take into account current threats and attack scenarios. Next, we recommend that GSM and CTIA coordinate on a survey of U.S. carriers to assess and measure the extent to which invalid and duplicate device identifiers may be used on their networks, and recommend that the industry reinstate a service to monitor and report device identity security issues to provide statistical data and ensure identified devices, identified problems are notified to the affected device manufacturers. The next one is asking the FCC to work with Congress to enact legislation to criminalize the unauthorized changing of device identifiers and to supply or process equipment to undertake this activity, and it should be enforced and offenders prosecuted as a disincentive to engage in this activity. And also, we encourage the FCC to facilitate the convening of operational law enforcement subject matter experts to discuss mobile device theft with regard to response, outreach, education, prevention, tactics, best practices, tools, analytics, and collaboration across jurisdictions. And finally, we have a number of topics we propose for 2016, so hopefully we met your timeline.
I appreciate, Brian, your work in actually naming that tune in 19 minutes. So that was overachieved, and actually, Mark, I appreciate your moving things very rapidly.
Just one other item. You have a report that you want to release.
Yes, we do have a report that's part of the package that we're delivering, so we'd like to release this and have this report published.
All right. Now, that has been disseminated to everyone. When was that sent out? I remember.
A week ago or so.
Yeah, so that you've had an opportunity to read it. All those in favor of posting the report that has been sent to you all, raise your hand. Opposed? And I saw your hand on the phone. That was very good. Dick?
You got it. Thanks.
Great. Okay, so we will post that. I would also suggest in your recommendations, a number of your recommendations were recommendations to CTIA, to ADAS, to GSM Association, and it would be my belief that many of those have been accepted by those organizations already. So while they're listed as recommendations, they
Yeah, both CTIA and GSM Association were members of the working
Right.
group, and they have already adopted and agreed
Yeah,
to.
so it's a slightly different form of recommendations. It's really an acknowledgement that the groups are taking on those challenges more so than recommendations for
That's
action by
correct.
the FCC.
Yeah.
And I think the FCC is delighted with that form of recommendations. Just speaking on their behalf. All right, very good. Our cleanup hitter, Steve. 477. Clicker. We so often put you in this cleanup mode. I apologize for doing so, but we...
Yeah, Steve, you're the only thing standing between us and drinks, so...
I don't know who's serving the drinks, but...
They're going back to work.
Oh.
Okay, can we
All right.
bring the slides up, please? Okay, great. So, the same working group. Basically, a quick update. We weren't asked for any specific testing assistance in the fourth quarter. However, there has been a release of broadband deployment data as of going up to December 2014. So you should be aware of that. And there's been no further changes made to 477 inputs. I had this slide up last time, And the reason I have it here this time is because I wanted to highlight that the alternative hypothesis that I posed only verbally last time, which is that when looking at the maps I showed, one could say that that the data itself in terms of coverage is incorrect, or one could say that maybe satellite is becoming more competitive. And so the main update that I have for you is to show some evidence that it's perhaps becoming more competitive. So I showed this slide last time. I'll skip over it. This is on the left, you see our old technology of Wild Blue, and what you see there are the densities of where our customers are in the Columbus market. On the right, you see the densities of where our customers are now in Exceed. And you can see that the previous densities are still there, but there's new densities, which is some evidence that at least in some places, satellite is becoming a stronger competitor. I showed this slide last time, which was the classic, showing how we tend to show up. Those are customers showing up in contrast to. Okay, there's. I'm sorry. Is your question on this slide? Okay. Yeah, this is just a concentration of customers. And this is the slide where it shows contrast in where our customers are as opposed to where there are served areas. And we tend to show up on the outskirts of town, which is more or less what you'd expect. Last time I also showed this slide in the Atlanta market actually, you can see around Atlanta that there's a circle of red, which means that we're showing up with densities of customers in allegedly served areas. But then if you go and look at the same thing in around Atlanta, in the Atlanta market, you can see on the left there's where our densities of customers are in Wild Blue, and on the right there's the densities of customers with Exceed, with far more. So this is the summary slide that I showed. No, green means served. The yellow is confirming underserved, meaning that there's a high density of customers in an area that is underserved.
Okay, thanks.
Certainly. The recommendations are the same as what I had said last time, which is we ought to resume work on 477 data collection, looking for improvements for accuracy, consistency reporting, streamlined workflow. We should apply the 477 data to improve the national broadband map, and believe that the FCC at least has been mandated to do that, but there are other issues that have been preventing that to move forward. Repeat the recommendation that to try to incorporate consumer input to sort of crowdsource availability data rather than making it simply something which is required through 477 reporting. That household level data has been deemed to be impractical, especially for smaller service providers. So the alternative to that would be to allow end users to report whether or not the people who show up as available really can serve them or cannot, and to just simply add that functionality. The last recommendation is we really think that the 477 testing group should be put on hiatus until you actually have more streamlining and accuracy work for us to do, and happy to come back and do that when you're ready.
Great. Any questions? Seeing none, we will move on, and I do not believe that we are where we are in time. The last three speakers are to be commended to the extreme, since it is still not yet the 4 o'clock hour, and we had allowed a little extra time at the end, which I am so glad we put 15 minutes at the end. We did not have 15 minutes of content at the end. But it did give us the buffer that we needed so that we will end approximately on time. What I would call your attention to is the schedule for next year. The one thing I feel quite badly about with this meeting, I feel that we've foreshortened a lot of the conversation, which is part of the richness of this body when we get together. We had such tremendous report outs of the great work that had been done. I would surmise that there was more interaction that the group would have liked to have had around some of these. And toward that end, it's our goal next year to remedy that situation. And I mentioned this at the very start as well. So this year, we did two things to change our way of operating. One was to have long and short presentations in the three meetings leading up to this one, and then a summary with this one. I think the long and short worked well. I think that this meeting did not work well. We need more time than what we had. And that bespeaks also the first early point that I made, where we have 250 people involved in producing things. We need more time at the end of the year to review them. So to do that, our goal is to make the final meeting of the next year rather than a 3-hour meeting as it once was, or a 3.5-hour meeting as it is now, to make it a 5-hour meeting, 2 hours in the morning followed by 3 hours in the afternoon, which would give us adequate time to really address the wealth of subject matter that has come up. The suggested dates are given here. There's an early objection on the December 7th date by one individual, as far as I know, based on the impact with Globecom, which exists right now. Globecom is going on, and to not have that impact. I will bias the jury, though Globecom is an important event which I've frequently attended in the past. Moving things up an extra week, losing a week in effect of our TAC deliberations, seems to be less valuable than having an impact on the overlap with Globecom.
Yeah, in fact, I'll add, I looked at going later back in time, but we're booked. The commission room is booked. And
that was the other alternative, to go the 14th or something.
And frankly, the 30th follows on the heels of Thanksgiving week, so there's no good solution here.
Yeah. So unless there's overwhelming negative perspective on the 7th, that would be where I would want to be. Pierre?
This is not a negative comment at all about the 7th. It's just a question about the long meeting in the end of the year.
Yes.
And it's a hypothetical, but what I look forward to is that there's going to be a lot more discussion. Mm-hmm. One of the things that might come out in the discussion is that when there is a group that's come up with a white paper, there might be a quibble about the white paper.
Right.
I would love there to be a way for the groups to respond to that with an updated white paper and get it approved without having to wait until March of the next year. As I understand it, because of the way we're chartered, we can only approve things in a public meeting. So, I guess that's a question for the FCC staff. But how do we allow
the designated federal officer?
Yeah.
If the changes are approved at this meeting, I think we can incorporate that into the document. You have to be explicit in the changes. But if there's an approval, for example, we've already approved an if possible statement from Greg in terms of his white paper. That I think that the problem is you're right. If there's a significant, we'll work on this and come back to you. The only opportunity to come back is going to be. The other possibility we can do is these don't have to be televised meetings. So we could have the other thing I would suggest off the top of my head, we could arrange an extraordinary meeting that would be an open meeting on a teleconference. And I think that would satisfy, I'll check with ethics, but I think that would satisfy the needs of the statute.
Lynn?
Question I have is, for the first 3 meetings during the year, could we start like at 12:30 versus the 1 o'clock to give us that little bit more time? Because it seems like we're always just running right up to the clock. So if we could start at 12:30, I think that'd be great.
By the way, I will note that in defense of the chairman, this never happened when Tom was running.
That's right.
Oh, okay.
When we had a real chairman.
Which chairman?
No, and it's true, and I feel quite badly about that, to be honest. But on the opposite side, the amount that you all are doing is just amazing. It really is amazing to me, and I have some opportunity to participate, but really, really greatly appreciate it.
Yeah, I mean, the FCC would love to have. I mean, we're very appreciative of the effort that you people have put in. I've attended a number of the work groups, so I've got a very good perspective. But if there's a consensus on 12:30, we'd love to have that.
Does anyone object to 12:30? Especially if we put the food in the room. All right, 12:30 it is. Julie.
Yeah. So, just a couple of quick things. First of all, just thanks for all the work. I hope you had fun with these topics, because I know I enjoyed the dialogue and all of the depth of thought that went into this, and the enthusiasm that I saw. We had a great set of topics. You put forth actionable recommendations, and for our part, we'll be discussing, reviewing them, and looking at what we may be able to implement. So we take all of the recommendations seriously, and we're going to see what we can do to make them happen. We also didn't quite get to the topics for next year. We got a fairly rich list of suggestions. Many of them were in the recommendations at the end. We really appreciate that. We endeavor every year to get a head start so that the March meeting is not talking about what we're going to do, but we're already rolling, so we're going to try and do that. And then lastly, I just wanted, and this is not farewell, to thank Dennis for all of the for all of the time and energy that he's put into this, especially as we've grown so large and had so many different topics to juggle, and all of this is on his personal time. And I just want a round of applause for him for all he's done.
You don't want the Lifetime Achievement Award?
No,
we're not through with them.
I appreciate that, but the accolades really go to the people that are doing the work. Designated federal officer, sir.
Yeah, one final point, and this occurred to me during this meeting. We've actually increased the number of FCC liaisons over the last several years on this. There's been a side benefit. I know participating in the work groups I participated in, I've learned a hell of a lot, and the others have also commented. So one of the roles that you have is to educate the FCC. You've educated actually a significant number of staff reporting to different bureaus within the FCC. We've been appreciative of the effort you've done. We've benefited from it. Some of the work groups have been incredible, at least the ones I've participated in, and I've heard similar comments, incredibly interesting and have expanded our perspective in terms of challenges that the Commission is going to face. One other comment I'll make, our FCC chairman, Tom Wheeler, is very big on working with industry, and I think the TAC is probably one of the best examples we have of working with industry in a way that benefits us, benefits hopefully industry, and certainly benefits the consumer. So I'd like to just thank you all, and wish you a happy holiday, everybody.
I've been on a number of working groups with you over the years, and you are particularly helpful. I think you're a real model for the FCC of how helpful it is when we have an FCC liaison in our working group. So I just think that deserves mention, because I've been on a lot of working groups with you. Yeah.
No, I think working with Walt, and Julie for that matter too, is really an enormous pleasure for me, and with all of the liaisons. It's a terrific group, and as you know, we do have steering committee meetings, so do pre-reviews of what's going on and what needs fixing and all of the rest, and it's just a terrific group to be working with. So kudos to the whole group, but particularly to Walter and to Julie for that matter for overseeing a lot of the work that we're doing. We will be moving forward with the goal that Julie mentioned. We do have the list, and thank you so much. I think this is the richest list that we've had at this time from the groups ever also.
Yeah, that's true.
Yeah, so it's a terrific thing for us to sift through. These items do need to be approved by the chairman, so be aware of that, and that's an important part of this process. And it is really important to all of us, because Tom really is paying attention. And you saw that at the start, all those blue check marks, and we did it fairly quickly. But the recommendations that you make are acted upon, and that's what makes this all also worthwhile. The work is work that is not an interesting academic exercise. It changes real policies in the government and makes life better for the citizenry of the United States, and that's a really big deal. So thank you particularly to the working group chairs, and this time I have to add the working group sub-chairs. In the way that we have continued to morph, the working group sub-chairs are doing a tremendous amount of work in addition to the working group chairs, but all of you are really engaged in a significant way in making a difference, and I greatly appreciate it. And I do add to the wishes you've already had for very happy holidays. Do enjoy them and get some rest, because we've got lots of work to do next year. Thank you, one and all. Safe travels.
Thank you. Thank you for letting me participate on the phone. Thanks, Dennis.